day 2 sessions, but this session is now merging with, this is like a coalition government, Karnataka style. Agriculture biotech companies are also joining. I don't know how many. Dr. Basuraj has come. I was telling agriculture biotech companies are joining, he's coming. Okay. See, whatever I'm going to tell will also be the question paper leaked with some answers also. So he is from here, Karnataka, but he went to US, came back to start. He has probably amongst all of us largest piece of lands. He starts making from wine to this and that, and also agri-biotech companies, which you are going to hear. So this is one question which is going to be there in your question paper. So we also have one lady from Manipur who accidentally stumbled upon this side thanks to Sesha, who has come all the way from Manipur here to start the biotech company in the Bionest in UAS. And she don't know much Kannada, but she knows more Tamil. Vanakkam Thaye Varga. She studied in Tamil Nadu, it seems. So you're going to hear from ag biotech companies and some more talks which are left. So this is going to be for all of you to tomorrow's join those companies or start your own companies, collaborate and do big. And your certificates will be given after that thing. And KP is very particular to know who are the people who are joining for dinner, which is not here, somewhere close by. How close by, only Sesha knows. It is crow flying, stone throwing, distance, I guess. Or maybe missile. So he knows the route to go. Yeah, a car is or 10 car gaadigal ide. Yeah, everyone hops into our house above some of the cars because I saw a lot of monkeys. Okay, we'll manage. Some of us can come back and pick up people also. See, the number already is being, only people who ticked in the WhatsApp group put a post and it's also on the top of the, it's pinned. Only people who have ticked will be picked up. Otherwise also people can come. For pickup, minimum you have to do. Also to head count there you have to do. Otherwise those days, no, after eating you have to grind idli maav and all. I don't know what they do nowadays. So be ready for it. So now moving on to the real sessions. Expertise is there. Expertise is there. So now I would like to introduce the person who's going to conduct this session completely. He has a company which is older than him, which he founded. I don't know how he did it. He's going to tell us. Maybe he's looking too young for his own good. So Shekhar Shuman, he is also IBIOM's one of the trustees. He has made a lot of difference to IBIOM, the Indian Biotech MSME Startups and MSME Trust. Please remember this. That's one of the questions. What is IBIOM? But it's all choose the best answer only. All answers will be close by. So Shekhar has been with us and he has been in the field for more than 17 years. His job itself is a job portal to find jobs for you, or if you want to get people, he will get. Even professors can use. If you want some good project students, he will help you find. And if you have opening seed companies, Basuraj ji, all note koli, he will get the right people for you. And he's big in AI. using computers for everything. And he is also kindly online broadcasting whatever after I finish. Only they will start with the boss. Whatever he is going to start, they're going to broadcast. And it will also be recorded and you can give to everybody. So people don't sleep. He has put cameras everywhere. So over to you, Suman, and I'm Shekhar, and I'm not running out. I'm making question papers setting up for you guys. Thank you.
Thank you, sir, and a very good afternoon, everyone. Thank you so much for joining us post-lunch. I hope all of you are ready for some action. So to start with, my name is Shekhar Suman. I'm a college dormitory entrepreneur, started a biotech edtech company, probably when there was no edtech also in India. So my company's name is Biotechnica, and it started as a job portal. Now we are into multiple things, including AI in drug discovery, bioinformatics, and of course, multiple other things. But for the biotech ecosystem, we are here today for the IBIOM. So without taking much time, we'll jump to that. And yes, like Raja sir said, we will be broadcasting this live. So if in case you step out for a loo break, you're not going to miss a thing because you can watch that later on again. So let's start with what is IBIOM. So as you all know, biotech or any type of life science startup has a longer incubation period, a longer hand-holding period than any regular startup. For an IT startup, all you need is a laptop and a few, RAM or something. But here, you require a lot of infra to start up, a lot of infra to scale up, a lot of regulatory approvals, a lot of intellectual property stuff to be done, and then only you are in the game. So the founder trustees of IBIOM, whom I'm going to show shortly, felt this need, and they are all well settled entrepreneurs, and they already had faced all these challenges, and they said, okay, why not make sure that the young entrepreneurs never face what we faced? And ladies and gentlemen, boys and girls, that's the reason we have IBIOM. So let's start with the next slide, please. So IBIOM started as a BBS group, as you can see, a WhatsApp group, a very humble beginning in the year of March of 2019. And then we moved on to register it as the BBS transformed into IBIOM, as you can see in February of 2022. Now, today we are present in more than 6 cities. We have 1,000 plus startup members, including many established companies such as Genotypic, Quatalomics also. And we are present in New Delhi, Bengaluru, of course, Tamil Nadu, Kerala, Mysore, and Mumbai as well. Now, what exactly IBIOM does is, it is a facilitator, coordinator, and a mentor group. So if in case you are planning to get into a startup or start your own startup, or you want any kind of regulatory approvals, any kind of hand-holding, any kind of networking, this is the go-to place for everyone. So here is the founding members and the trustees of IBIOM. So we have Dr. Raja Mogasi Mangalam. You have been interacting with him for last 2 days already. So he is the chairman, honorary chairman. Then we have Dr. Jagdish Mittur, president of IBIOM. And we are so thankful for all his contributions he keeps bringing to us. He has a big network within the government also, and that is how the Karnataka government is connected to BIRAC, and he brings us a lot of benefit from the government side as well. Moving forward, we have Mr. Naveen Kulkarni, who is the secretary. Ms. Divya Chandradhara, she's not here, so she's the treasurer. Then we are the newest trustees. We have Dr. Manish Paul. He's the AMR warrior, antimicrobial resistance is picking up, and he's the co-inventor of N-metazobactam, and he's one of the trustees. Followed by that, we have Dr. Varsha Sridhar and myself. I'm one of the youngest trustees in this group. We also have our geographic units held by Dr. Palani Muthu, President of the Tamil Nadu IBIOM chapter, and Mr. Hargaran Dhingra, President of the New Delhi IBIOM chapter. We also have the legal advisors, Mr. Kirit S. Javali. He is the partner of Jaffa and Javali, Barrister Advocate, Supreme Court of India, New Delhi. So even he's a part of IBIOM. Moving forward, let me quickly brief you exactly about what exactly IBIOM is doing and what it is about. So we are a platform, a pioneer platform dedicated to supporting the startups who are just getting started, are already in process or want to scale up. They want any support from the government side. They want any support from the investor side. They want any kind of hiring help. They want any kind of mentoring. You can count upon us. In fact, today is the 46th meeting where we are sitting today in the IBIOM. We have conducted 45 prior meetings. I'll be showing you about that as well. We have a custom and tradition that we conduct these meetings at a different venue each time, mostly hosted by some other startup member. And today we are thankful to UAS for allowing us to host it here. Our focus is on biotechnology sector, and that of course includes all the allied sciences in biotechnology, which of course let's call it as a life sciences, including agriculture. We have a lot of agri-biotech and agri-tech companies as well in our group. IBIOM has been playing a crucial role in fostering innovation, encouraging collaboration, and driving sustainable growth of the industry. Just last month, one of our IBIOM member acquired a Switzerland-based startup. So such is our coverage that even globally we are now acquiring startups as an Indian company. So these are the challenges which IBIOM is trying to cover up, and these are the IBIOM MSME logos, as you can see. So we are trying to help startups get funding and disbursement of timely funding from relevant departments, such as Government of Karnataka, IT, BT, and ST. And of course, we also are collaborating with BIRAC. We have an MOU in place. So that we can help any budding entrepreneur grow in this ecosystem. We help startups to become scale-ups. We help them make resources accessible through biotech infrastructure, logistics for manufacturing. We help with reaching out to rural sectors. We conduct a lot of workshops in villages, all thanks to our president and chairman. We conduct a lot of such workshops for students in schools, in colleges. In fact, last month we were in Ramaya, if I'm not wrong. We conducted a workshop there as well. And we help, because as you know, biotech and life sciences startup need a lot of regulatory support. So we also help provide assistance with customs and regulatory clearances as well. So these are the challenges which startups are facing today, and we as a consortium, as a foundation, intend to address. The next slide is not moving. Can you check? Yeah. Okay. So here is a links of all the partnership we have. So we are in partnership with Government of Karnataka, Bengaluru Bio Innovation Center, Atria University, BIRAC, Department of Biotechnology, and we have been collaborating with them for several years now, and we are here to continue this collaboration and supporting the biotech ecosystem. We are in resource partnership with Bengaluru Tech Summit, Genomics India, Global Bio India 2024, and IAC Bengaluru. IBIOM has proudly served as associate partner for BTS, as a knowledge partner for Genomics India, Immunocon 2024, which was conducted at IAC, we were the knowledge partners. And then additionally, we are honored to be supporting partners of Global Bio India 2024. IBIOM has so far conducted not 43, actually 45 meetings. From startup to scale up, one of the few examples I'll give you what kind of workshops or meetings we conduct. One of the meeting highlight was how can a startup convert into a scale up and what is the role of government and what is the role of intellectual property into this. Then we have conducted meetings on how can we nurture academic talent and they can start their own bio entrepreneurship journey with us. And along with the new financial year, we keep coming with new opportunities. So this kind of meetings also we conducted where you can utilize digital marketing and personal branding to grow your startups. Then we also conducted a startup on why should we worry about climate change. There was a panel discussion on bio-entrepreneurship opportunities while you mitigate climate change. So we as entrepreneurs are looking at climate change as not a problem, but as an entrepreneurial opportunity. So even that, we have conducted meetings in the past. These are the venues where we have conducted. We have conducted meetings in Creagen, Rico, BioAgile, Quatelomics, Biotechnica, Eden, QuantumZyme, Atria, Bangalore Bioinnovation Center, and various other places. So if we look at, this is one such meeting, but I would welcome everyone to network, meet and greet and reach out and find out how can we help each other, because at the end of the day, it's the networking which immensely helps startups. And this is one such opportunity today. Now, coming to the registration, it is very important to know that we cannot help if we don't come together. So IBIOM has a small registration fee, which as a member you can pay to be a part of this network. And if you are a part of this network, then your logo is displayed on our website and a link to your website so that other startups can find you out, not just in this meeting, but of course after this as well. We also have a MSME marketplace where you can enlist your products and services. We give you opportunities, not just offline, but online networking opportunities so that you can reach out and find people who can do the miracle for you, because startups is all about finding the right people. Marketing, that's also very important. Suppose you're launching a product, you need the key people. In fact, last month, like I said, when this IBIOM member bought or acquired another Swiss company, we were able to have the minister from government of Karnataka come and grace the occasion. So you can imagine that's the kind of reach we have. We also help you in set up your HR, DSIR, and other registrations for startups. And of course, like you can see outside, you get a chance to display your products and services, which will help you reach out to more members, more buyers, and of course, it's all about marketing, right? So there's no harm in reaching out to the members. Then we also help you showcase your products in our virtual group and all the launch events which we keep coming up with. And we also have an investor connect where you can meet the investors, talk to them, and find out if they would be interested in your startup. In fact, even today we have a startup pitch event scheduled during this meeting. So as a member, if you want to become a member as a early stage enterprise or a pre-startup, you can pay, or as an individual, you can pay 2,500 rupees. If you're an early stage enterprise, you can pay 10,000. If you're a micro enterprise, 20,000. If you're a small enterprise, 30,000. A medium enterprise, 50,000. A gold patron, 2 lakhs, and a sapphire patron, 5 lakhs, and platinum patron, 10 lakh rupees to support the IBIOM's cause and initiative. IBIOM is here for you. IBIOM is here to support entrepreneurs pan-India, but we cannot grow if we all don't come together. So thank you so much for your patient hearing. I hope I was able to do justice. This is the first time I was given an opportunity to talk about IBIOM in any one of the meetings, and I'm thankful to Raja sir and Jagdish sir for this wonderful opportunity. And thank you so much, and have a great meeting. Thank you.
Yeah. Can you see the schedule?
Yes, I'll start that. So the first talk will come out.
You have the schedule with you?
Yes. Yeah. All right, so let's get started with the meeting. We are slightly running late, but never mind. Doesn't matter, never better. Let's get into it quickly. So we have the welcome note of this meeting from Professor Dr. Shesha, Department of Plant Physiology, US, Bangalore. Sir, please, if you could come up to the dais. Thank you.
There's no need. Good afternoon, and as he said already, you had a good lunch. My intervention was absolutely not necessary at all, and I would simply say that welcome back again for this one. But I have only one question to ask Jax and others. There was an article that I read very recently that the Indian startups, 80% of them fail within 2-3 years. And we were all reviewing projects in the BIRAC in one of those committees. They don't come back. They look at this as an opportunity for, let us say, 18 months of salary for these young entrepreneurs or something like that. Why does it happen? I mean, if your IBIOM can think about it and solve this problem, because the contrast happens in Japan. 80% of them become scale-ups. In your experience, what is the kind of scale-up that comes from the startup? I think it is only 20% or maybe more.
I think it's a very fair question. The structure, the ecosystem that we have is not really congenial for startups to move up.
Yes.
So to start, I think we're very good. Government gives a lot of grants. Karnataka government gives a lot of grants in various schemes. So does BBT and BIRAC. Unfortunately, many of the startups, there are a lot of startups, Me Too startups, right? So it's very difficult for them to really sustain unless they get proper advice from some of the big people like Raja and maybe Professor Agri-Genomics, because they've been through that. So maybe we can. So with that,
I mean, agri startups especially, it's always a stumble block somewhere. For example, I was helping someone some years back, and I was talking to her. We applied for a patent 2-3 years ago. Nothing seems to have happened. It's an Indian-make system, make in India, made for India, or whatever. And the same thing that that we struggled hard for so many years for getting the funds from government of Karnataka. Nobody wants to sort of understand that there is a new way of doing things. I mean, this is something that your IBIOM can address. It will be very, very nice.
We are addressing the way when we are welcome, and sometimes we go knock at the door of the Department of IT. Unfortunately, the country, including Karnataka, they look more at IT than BT. Some of them don't realize that you've got to have your tummy full before you can operate a computer. I think a lot of them take it for granted. We've been talking about, what is India today, Bharat tomorrow. That's what so we have Vajpayee said.
Oh, okay.
India today, Bharat tomorrow, IT today, BT tomorrow. The BT tomorrow is going on.
Tomorrow will never come. We only did not use.
My point is that we have to make people feel hungry.
Yeah.
But there are breeders like Dr. Andy who keeps producing yourself, and many others who keep producing food. We keep producing more and more per acre, and almost we are spoiled to all this.
Correct.
So unless we are hungry to be successful in biosciences, it's quite difficult. And funding is many of them don't get funding. Initial funding is good from the government, but you have to sustain funding from angel investors, or you have to take risks, like what Dr. Basrat or many others have taken risks. We have to sustain. So if you don't do that, the young entrepreneurs, you have to understand that right up front. So don't just get into, I want to be a startup, I'll be a CEO, all this, CEO have become very popular now. Everyone is a CEO, but for what reason?
Correct.
So we need to, this is a bigger issue we can discuss.
During that. So this is, just that for the young people, this is what I wanted to say. Most of you look for JRF and research associate positions or postdoc positions. That is one part of it. Other than that, if there is anything which is very, very something fantastic that you have done, and I think it should be useful to sort of take it up forward. And if IBIOM and such organizations can help the young entrepreneurs, I'm sure there can be a lot of progress that can be made. And that's all what I wanted to say. And welcome to my campus. I'm glad that your IBIOM meeting is happening here, though I was oblivious of this. I did not know that you existed for 46 meetings. Is it 46 monthly meetings or?
Yes, monthly.
Oh, okay. Wow. I did not know this. With whatever I was doing, maybe. So all the very best for this. I would be a part of this and listen. And then I think we should make use of the kind of services that they can have for the startup programs. I did mention it to the startups that we have in US, Bangalore, but Unfortunately, Dr. Veena has some personal problems, so she couldn't communicate this effectively. So it's okay. We can convey this. She will convey this to the rest of the other people there we have, and then we'll see what can be done. Thank you so much.
Thank you so much, sir. That was really insightful, and we hope that as IBIOM will be definitely able to address this and reach out to more startups and government people in power who can help things make things happen. So without wasting much time, now we have the next speaker, Dr. Sharan Angadi, Director, Foundation of Advanced Training in Plant Breeding, ATPBR, and he's going to talk on genomics in private sector, plant breeding, myths, realities, and market impact. Sir, please, if you could come up to the dais.
Good afternoon. I didn't hear. Good afternoon, sir. That's better. Because it's very difficult to talk to an audience which has already been fed with good lunch. Thanks to Shesha Sai. Generally, I ask what are the two kinds of lunches? I think some of you may know this. There are two types of lunches. What are they?
One which makes you sleep.
One which makes you sleep.
The other one which makes you run to the bathroom. Very calm.
Good attempt, Dr. Shesha. He says one which makes you sleep, another one which makes you to run to the bathroom. But my definition is one is called a working lunch, another is the lunch that works. I don't want to see any lunch working here. So what I will do is I'll just give a brief. My background is I worked in public sector for about 15 years and then thought private sector would be better. I changed to private sector, worked there for 22 years. Right now we have our own foundation. We call it as Advanced Training in Plant Breeding Foundation, a service organization, not for profit. We try to develop and then disseminate the practical plant breeding knowledge. Yeah, I know yesterday there has been a good talk on Agri-Genomics and how it is being used in rice. I think Professor Shesha spoke about it. And Raja has already spoke. I'm not going to tell you anything about genomics. As I said, I was in public sector for about 15 years. I am in plant breeding for the past 50 years. 74 is the year I started with plant breeding. I'm still continuing to be a student of plant breeding because there's a lot to learn. Things are changing. By the time you know it, you have learned it, there is already something new coming up. And I, for one, have been very amazed with the changes that have been happening. When I was in MSc, there was biometrics. Then came mutation breeding. Then came protoplast fusion. Then came genomics. So many things. You keep on being bombarded by all this. And then when we know in private sector, I have specially chosen this, in the topic, in the sheet, it is private sector. But I've changed it to market-driven plant breeding. That involves both private and public. I don't want to differentiate between me and them. It is us. Ultimately, as plant breeders, I think we need to work for the products which can sell in the market. That's why I used it as market-driven. As I said, in the last 50 years, we have been seeing so many changes happening. So many claims are being made. For me, at least, the application of genomics in commercial plant breeding or market-driven plant breeding is at least 30 years old. So instead of again saying what's happening, what is good, I thought a kind of stock taking we'll do, a kind of reality check. What are the promises? What are the myths? What all it promises? What all it can deliver? Myths, realities, and market impact. That's what I'm going to mention in the next 15 or 20 minutes. Yeah, I joined plant breeding thinking it has no maths because somebody told me plant breeding is an art. People said those days, you imagine, some of the varieties which were developed are bred. Those people are not even graduates, I'm told. So I thought this is a nice area. I don't have to go for maths. Maths, I'm mortally afraid of maths, like many of us. I thought plant breeding, there is art. I can do something there. I went there. Then they said art and science of genetic improvement of crops. That was slightly changing definition. Then they said art and science of changing the traits of plants to produce desired characteristics. Probably by traits, they mean genetics characteristics is something which is delivered, output traits. Then art, science, and business of genetic improvement of plants. So business came in there. That's how the private sector came in and started making good use of the technologies that are available to develop innovative products. So I thought the current definition could be purposeful modification of plants for a speedier creation of innovative varieties. Imagine, look at that complexity with desired trait blends combining conventional methods with advanced science and techniques of marker-assisted breeding, genomic selection, gene mapping, genome editing, speed breeding, precision phenotyping, and marker-assisted selection to develop crops that can better cope with emerging pest diseases and climate changes. A tall order, right? So many things to be done. So if I had known all this, I wouldn't have entered plant breeding arena, probably. You look at the kind of lists we have. And then plant breeding and breeding research are a collective responsibility of public organizations and private enterprise working together. That is why we need to call it, I think, as market-driven plant breeding. To do this there? Yeah. So then you may ask, what is that you do differently? Do you do something different in private sector than what is done in public sector? This is a question many people ask me. As they say, we don't do different things, but we do things differently, like winners definition. So focus is on developing crop varieties to meet the specific needs of end users and markets. So for that, when we know markets, we need to do market analysis. For that, we need to understand demand, identify target markets and consumer preferences. There are many: taste, color, size, nutritional value, etc. Then economic feasibility, assess the profitability of breeding programs for the intended markets. Stakeholder engagement, collaborate with farmers, processors, distributors, and retailers to identify their needs. Trade prioritization is very, very important because we think of product quality, improve attributes like flavor, shelf life, and processing characteristics. Adaptability, develop varieties suited to local climatic conditions and farming systems. Yield and resilience. I think Dr. Professor Ramegowda talked about resilience in this morning. That's another important thing. Enhance yield potential and resistance to pest diseases and environmental stress. Then we come to integration of breeding tools. Conventional breeding. That's what ultimately everything depends on. You may have a lot of tools, techniques, genomics, or whatever, but ultimately everything has to be realized by conventional breeding. So conventional breeding utilizes traditional crossing and selection methods that you cannot do away with. Biotechnology, apply marker-assisted selection, genetic engineering, or genomic prediction to accelerate the breeding process. Data analytics, use advanced data analytics tools to predict outcomes and streamline breeding cycles. And all this has to be farmer-centric. Farmer-centric approach, I mean cost of cultivation, ensure new varieties reduce input costs, example, water, fertilizers, plant protection chemicals. Accessibility, ensure seeds are affordable and widely available. Capacity building, constantly train people, provide training and technical support to farmers as well as the people working in that arena. Then we have regulatory and certification compliance. This is, as I said, just to give you a feel of what exactly is market-driven plant breeding. We have regulatory compliance. I think there was a talk on that a little while ago. Quality standards, meet food safety and quality standards for domestic and export markets. Environmental sustainability, align with sustainability guidelines. Water use efficiency, biodiversity, etc. Consumer trends and preferences, nutritional value, organic and non-GMO, aesthetic appeal, all these come under those. Value chain integration. Here, I don't want it to go into those details, but then here it has many aspects. Value chain is the one into which you have to coordinate breeding efforts with other stages of the value chain, from production to marketing, ensuring smooth adoption of the new variety. Continuous feedback loop from stakeholders to refine breeding objectives and process in response to market demand. These are the specifics of market-driven plant breeding. This is just I wanted to emphasize. So we wrote a book also it was published by ATPBR. We called it Market-Driven Plant Breeding. We have covered all the aspects in that. It has increasingly embraced genomics to meet the demands for higher yields. improved quality, disease resistance, and environment resilience I mentioned already. While the promises of genomics are compelling, a reality check reveals both significant achievements and critical challenges in integrating these technologies effectively into market-driven plant breeding. We'll see what are those. Achievements. What are the achievements? I think one of the major achievements is marker-assisted selection. Talk of several other things. You talk of proteomics, you talk of several other things. But marker-assisted selection is the one which has made a major change. Genomic markers allow breeders to select plants with desirable traits early in the breeding cycle, very well known. This has accelerated development of crops with drought tolerance, pest resistance, and improved nutritional profiles. Genomic prediction is another area. Machine learning and quantitative genetics enable breeders to predict plant performance based on genomic data, significantly reducing breeding timelines. That's a major benefit of genomic prediction and selection. CRISPR and gene editing, that is becoming very, very common now. There are many gene-edited crops using the CRISPR technology. Then genomic data integration is happening. And then consumer-driven traits. It's market-driven. Basically, market is what? Consumers and other stakeholders. Genomics help align breeding efforts with market demands, such as developing allergen-free peanuts, high-protein grains, healthier vegetables, or naturally sweeter fruits. In market-driven plant breeding, what are the myths? We'll just take a quick look at what are the myths, what are the realities. Genomics can solve all breeding challenges. There is a misconception that genomics alone can address every breeding issue. In reality, environmental factors and complex traits require a holistic approach. This has to be holistic. Only large companies use genomics. That's also not correct. While large corporations initially dominated the use of genomics, advancements in technology have made these tools accessible to medium and small-scale breeders also. Genomics means genetic modification. Genomics is often incorrectly equated with GMOs. However, many genomic techniques like marker-assisted selection and genomic prediction involve no transgenic modifications. This is a myth, of course. Breeding becomes instant with genomics. Although genomics accelerates certain processes, crop breeding remains time-intensive, requiring validation of field testing. As I said, these are all tools. Don't mistake the tools for the final end product. That has to be again from breeding. Challenges and limitations, economic feasibility. Genomic tools can be expensive to implement, particularly for small and medium-sized breeding operations. High initial investment in infrastructure and expertise may be out of reach for breeders in developing markets. Complex traits. Traits like drought tolerance or yield often involve multiple genes interacting with the environment, making them challenging to optimize through genomics alone. Phenotyping remains a bottleneck. High throughput phenotyping or HTP technologies are still evolving. Then there are regulatory hurdles. Gene-edited crops face fluctuating regulatory frameworks globally, leading to market entry delays and uncertainty. This I can tell from my global experience. This is not only specific to India. These regulatory hurdles are there everywhere, and they are not stable. They are not constant. They keep fluctuating. They keep on changing. So that's one big challenge which we face. Public perception of genetically modified or gene-edited crops can impact adoption rates. As you know, in Europe, there is not very friendly thing about genetically modified crops. That can be a hurdle. Challenges and limitations, market prioritization. Breeding programs often focus on high revenue crops, potentially neglecting orphan crops that are critical for food security in some regions. Traits prioritized for markets, example, aesthetics or nutrition, may not align with broader societal needs because nutrition is primary, then aesthetics comes later. Data integration and analysis, integrated genomics with traditional breeding data requires robust bioinformatics tools, which many breeding programs may not be able to afford. The vast amount of genomic data generated demands skilled professionals and computational resources. Then we take a quick check, reality check, a balanced perspective. Optimistic outlook is genomics has certainly shortened breeding cycles and improved the precision of breeding efforts. This has allowed breeders to meet market demands more efficiently while addressing challenges like climate change. Then ground reality is, despite advances, practical limitations like cost, regulatory issues, and complex trait integration need to be addressed to fully realize its potential in market-driven breeding. Collaboration between public institutions, private companies, and policymakers is critical to bridge these gaps. Again, it comes to PPP, another big area. Genomics offers transformative potential, but its success in market-driven plant breeding depends on sustainable investments, equitable access, and alignment with the broader societal goals. They are very, very important. What is the industry impact? Has it impacted the industry? It has enhanced crop productivity, market differentiation is happening, then faster breeding cycles, already mentioned. IP and regulatory challenges are there. They need to be overcome, but that has, of course, created many newer challenges. Increased competitiveness. Smaller companies and startups are leveraging genomic tools to challenge established industry players, fostering innovation and competition. I think that's one good development that has happened in the industry impact. What is the way forward? We all talked about all this. Affordable access to genomics. Continued innovation in cost-effective genomic technologies will ensure broader adoption across companies of all sizes. Focus on sustainable traits. Breeding efforts should prioritize sustainability traits such as reduced input requirements, carbon sequestration, and climate adaptability. Then strengthening public-private partnership. I think this has to happen more than what it has been happening so far, and it has to happen more intensively. Then only things can be better. That's why I use the word market-driven. Don't differentiate public-private. Then regulatory harmonization, efforts to harmonize global regulations for genomic technologies, particularly non-GMO breeding methods, will facilitate market growth. Capacity building, because these are new things. I think that's what has been happening since yesterday. Training programs and knowledge sharing initiatives will be critical for developing expertise in genomic breeding and associated disciplines, and integration of artificial intelligence and big data. Combining genomics with AI and machine learning can improve predictive modeling and accelerate breeding innovations. These are the points I wanted to make. Thank you very much. Any questions?
Actually, you gave a lot of questions for me to add it. To
Question paper is leaked, as you said. Okay, thank you.
I have one.
Okay.
So, what is the difference between GMO and edited?
GMO and?
Edited gene.
Okay. I think Jagdish can answer this part.
I will try. Okay, so there is still this universal debate. The debate is going on in multiple countries. Depending on what the country's regulatory agencies classify gene-edited crops versus transferring gene from other species to your plant. So one is cis editing, where basically you're editing the genome of the plant itself, but deleting a gene or adding a gene or modifying a gene to that plant itself. Okay, that's CRISPR-Cas9. That's one. So there's no foreign gene literally coming into it. Whereas GMO is where you have foreign gene coming from another source, which could be bacteria, which could be another plant, which could be something else. So that's the difference. They have regulations, but whether there are uniform regulations across the nations is still not clear. So it depends on what your country regulators understand. So for me, GMO is as good as any other crop. Okay, so it's still valid for me. It's safe and safe for me and all that. But many people don't think so because they get exaggerated about, oh my God, what's this gene doing? What is this gene doing in my food? And we have so many bacteria within our system, microbiome. There's trillions of bacteria within our system, which all have their own DNA in it contributing to it. So people who are opposed to one gene coming into, for example, BT cotton, 1 or 2 or 3 genes coming into your crop, to improve the traits, to be drought tolerant, to be pest tolerant, to be herbicide tolerant. That makes it easy for farmers. The people who generally, I'm talking about generally, who regulate these things are people who don't seem to know what the farmers really face. Like yesterday, Dr. Nair told me, the Dean of the University of Houston, there are so many challenges farmers face. How do these regulators know about these challenges? So that's something that we have to understand. Hopefully, people here, while you're learning about technologies, when you're actually doing an experiment where you're going to bring in a foreign gene for the benefit of the crop, so it can sustain better, and more so for the benefit of the farmers who grow these crops, and more per acre as the population increases to billions per billions. So we need to grow more in less acre. That's the challenge for the gene technology, CRISPR technology. So people should understand.
Yeah, I'll just add to what he said. Like he said, genetic modification involves transfer of a gene from any species to any species. Otherwise, we know there are species barriers. We cannot, rat and man, you cannot transfer the genes. So there, because of the technology available, that was possible. But then it generated all kinds of funny arguments. Like you must have heard of Arctic flounder. There is a fish, Arctic flounder, highly resistant to freezing conditions. They wanted to put their gene into tomato to make it to grow in freezing conditions. Orange also another example. Then the vegetarian started asking, is there a fish gene in my tomato? How does it matter? Eating a fish gene tomato became a problem. So all kinds of funny arguments happened. But as I said, edited crops are much more friendly, and I think they require less of regulation as compared to gene modified or genetic modification is now, but earlier they used genetic manipulation. Manipulation gave some kind of funny feeling. They said, no, don't call it manipulation. We are not manipulating anywhere, only modifying. So many funny things. But then I think now CRISPR-Cas being more widely used, many crops are being edited, and there are many crops in the market which are already gene edited. I think they require a genetic regulatory approval or?
Go through the agencies, but then they get.
Okay.
I'm not sure if there's any such CRISPR-Cas edited crop being released in India. Not yet.
But they are looked at as more friendly than GMO.
That's because the plant's own gene.
Yeah.
India CRISPR edited mushrooms, or most of the mushrooms you are buying are all CRISPR edited mushrooms. Otherwise, in one day, morning to evening itself, it will now what we are having mushrooms are all
Shelf life, it has a better shelf life.
Yeah, much better.
This one I had one more. Thanks for asking the question. We always into this debate here. So this shows how hypocritical we all are. How many of you had COVID vaccines?
Otherwise, they wouldn't allow us to travel.
Exactly. And the COVID vaccines were of several types. So here's a situation where you have forget the name of the COVID brands. Covaxin is one which is AstraZeneca. So they adenovirus vector. And this virus takes a virus. You let them put the core protein gene or the surface protein into the vector. And they directly inject it into your bloodstream. It's a virus carrying the gene. Did any of you ask questions? Now you're asking about beta, which has been proven it's safe and secure and all that. Invented by our own Harvard, University of Harvard, doing very well in Bangladesh, right? And yet our regulators don't know that. Regulators themselves would have had COVID injections. Did they ask any questions? No. This is the true hypocrisy of the mindset of people.
Because yesterday also we spoke about this. I think there are multiple views about it, and we do not fully agree with everybody that you are going drinking beer, right? They are all 5,000, 10,000-year-old strains which are drinking beer, whiskey. Some of them are native strains. Nobody wants BT modified yeast to make the beer. So, but yeast is the one which was genetically all studies are done. Still, not even any company dares to sell that. Whereas for medicine, all of them are GMO, everything. But it doesn't mean that we have to accept GMO everywhere. It is humans' taboo and feelings and things are there. We cannot question them.
There are only two kinds: hypocrites and analysts. And in this very rule, people who use glucose in their water and people who don't use glucose are keeping the other person wondering whether that's the message or not.
So in this very room, we had a talk by the great guy called Edwin Sutherland. How many of you have heard about Sutherland blotting?
Sudden blotting.
Edwin Sutherland was the man who made that. And he was here talking about GMOs and everything. One of our professors, he got up and asked him a question. Why are you doing all these things? Isn't it blasphemy? Oh, you're becoming God? You're doing something?
No, then you are hypocrites. Are you ready to
Do you know what he said?
genetically change yourself? How many are ready to genetically manipulate your gene instead of taking a medicine?
You know what?
We are not hypocrites.
It depends on the kind of disease you have or your child has. Okay.
No, what he said.
Look at that. If your
No,
child, if your
When
child,
Southern said this too, he said, "Oh yeah, sure, you are right. You are all blasphemy idiots. Do you eat sugar?" He said, "Yes, I eat sugar. I like sweets." You are a bigger hypocrite, bigger blasphemy. Why? It's a chemical. And you are eating that chemical. DNA is a chemical. How can you call me like that? How dare you? Do you know who I am? That has to happen. Somebody should get up and really tell them to hell with you guys, this is what you have to eat, otherwise you will die. See, I mean, this talk that he has given, I mean, market driven breeding is something excellent. If the market drives us to now develop something, yesterday they were asking this question, what will happen if you do not have a resistant source at all in the germ problem? How can you do breeding? So we said, go mutate, go do something. And why don't you introduce it somewhere else? This ice gene that we took in from that fish is one of the most easy things to do. I don't know. Oh, this tomato has.
anyway, all the products that have been released so far to GM technology are genes from bacteria or plants, nothing from animals so far.
But you know, you say this, no, the regulators. I was a member of the RCGM. I'm an agriculture graduate. What do you mean if I don't voice up and tell them that whatever they are talking about is nonsense? RCGM is only a regulatory authority. GEAC is the apex committee. GEAC is full of politically influenced guys. So RCGM doesn't talk to GEAC, it is the problem. What?
We are looking forward to a couple of GM masters
Oh, yeah, so
Thank you.
GMC,
from
Deepak Penta.
Deepak Penta. Such a beautiful
Yeah.
product.
What else can we need?
And we import crores and crores of rupees from palm oil.
Yeah.
Morning, we
Discuss that.
So thank you, Dr. Sharanagiri sir. It was really insightful. The part which really excited me was the AI because we are very soon going to see a plant double of whatever species inside a computer and growing it in virtual soil and finding out what's going to happen. But let's not deviate from the agenda. Let's get back to what we are here for. So now I have Dr. Manish Kumar Thakur, Associate Vice President, Genie Labs, to talk about development of molecular tools for agriculture. Sir, if you could please come to the dais. Thank you.
So there is no. This one. No, this I understood. No, this I'm asking. I need a. That's not working. You don't have anything else? Because then it will be difficult for me to. Okay, then leave it. It's okay. Oh, very good afternoon. And the last two sessions we have discussed about two things. Even I will start from there only. One thing about the lunch. There was two different kinds of definition in the lunch. My definition is a bit different. In any conference, in the last day and second session, sitting is very, very difficult. So please bear with me. I will not take much of your time. That I am assuring you. And then we discuss about a startup. Yes, even Jenny, we are a startup. Correct? We are very, of course, we have started this company in 1989, but there was many ups and downs about Jenny. But again, we are returned as a startup. So about me, I am Manish. I have done my PhD in biochemistry, my postdoctoral work in structural biology. And last 15 years, I was more in drug discovery. I'm not agricultural biotechnologist. I did drug discovery. And recently, 2.5 years back, I joined this organization called Jenny Laboratory. So I'll be talking about my products I have been asked to discuss because I represent Jenny. It's an organization. I'm not going to talk about more of CRISPR and other things that was in my mind, but I have been asked just to go and show our products. But anyway, come back to CRISPR. I will take 1 minute of your time. I am lucky. I met Jennifer Doudna long back before she got the Nobel Prize. And during my meeting with Jennifer, I asked her, why are you working on the CRISPR Cas9? And that time nobody knows about the CRISPR and other things. Technically, you must know Jennifer was hardcore structural biologist. I can tell you, her PhD was in the structural biology. She solved the structure of some RNA and ribosome. So I met as a structural biologist to her. And when I met her, she was telling me, I'm working on the CRISPR, I'm working on the CRISPR. We were not knowing anything about CRISPR that time. Later, she got Nobel Prize. And what I did, I brought her postdoc from US to India when I was working for the organization called Syngene. And we have started CRISPR in Syngene, but mostly for the big pharma company, nothing related to agriculture. Then coming back to Jenny, as I said, Jenny is the more or less first molecular biology or biotech company in this country. It started in 1989. We deals with all different kinds of enzymes, correct? Both for the educational purpose as well as for the industry purpose. We have all kinds of certificate, what you call ISO 9000, ISO 13485. Recently in 2021, this is acquired by Rivara Group. Rivara Group was the promoter of Bharat Serum and vaccines. And then people like us, we joined this organization. Correct? So what we do in the Jenny, we manufacture all kinds of enzymes, diagnostics kits related to molecular biology, biotechnology, or biochemistry. What two things is important for any individual's life? First one is the food. To have a good food, we need a good agriculture. To have a good agriculture, because we are talking about agriculture biotechnology, we need a good agriculture biotechnology. To run a biotechnology lab, you need all different kinds of enzyme, etc. So the company, we provide all support for agriculture related, any kinds of molecular biology and other things. Second important thing is health. Correct? To have a good health, you need a good diagnostic systems. Medicines comes later. Correct? Even you start today working on one medicine, after 20 years it may come, it may not come. I can tell you, at least we would have started with 10,000 molecules. And at least in my 15 years, hardly one molecule even not reach into the market. Still, it's on the phase 2, phase 3 trials. But to have a better diagnostic system, it is very easy. So even our company, we support all the diagnostics. Correct? We have a different kinds of a kit. I will discuss about them in a couple of minutes. The infrastructure about Jenny, most of the people who would have done 10 years back, either their masters or PhD in biotechnology, biochemistry, they would have used our product. I'm assuring you in their thesis, if you can go and check, there will be name Bangalore Jenny. We are same, now Jenny. Today we have around 50,000 square feet infrastructure, 35,000 in the Pinia, that is our old campus. And recently we have built up around 50,000 square feet in the Electronic City phase 2. Pinia is mostly for the GLP grade lab. And in the Electronic City, we have a GMP grade where we are going to manufacture all different kinds of enzyme and the kits. So recently, my team has developed all these enzyme. I will come back later why we are developing again this Taq DNA polymerase and other polymerases. It's already there in the market. I will come back to that. Then we were discussing about CRISPR. Yes, we also started, because we are a reagent company, we are not doing any science related to CRISPR, but we are developing all the steps required for CRISPR. Correct? And these all, because this light is not working, correct? All these enzymes is good for any agriculture-based work. So first, I'm talking about the Taq DNA polymerase. This Taq DNA polymerase, I think from last 20 years, people would have used. But now question is why we are developing again tech when already techs are there in the market and that to hundreds of companies providing that tech. Once we have started, because this is agriculture platform and I heard many seed company are participating. So with my own survey, we found the most important things required in the seed company or seed biotechnologist is the tag DNA polymerase, all the master mixes. And the costs were very, very high because most of the seed companies, they were procuring all these materials from the outside. So we started developing this tag directly that will be good for the plant because, you know, there are different kinds of inhibitor in the plants, particularly the okera, bindi, this type of things. It's very, very difficult to amplify. And getting a master mix for that is very difficult. Whosoever is working on the seed, they will tell you out of 10 master mix, even one works, that itself is a big deal. What we did in this tag, correct? So we have mutated. Again, I'm assuring you, this is a unique tag that whatever we have today, correct? We have a different kinds of mutation in this tag with our own structural knowledge and other things. We have done that genetic engineering. Normally, if you see, people will tell you tag will amplify for 1 kb, 2 kb. I am assuring you our tag will amplify for 6.4 kb without any issue. Correct? Then couple of example I am showing you. As I said, this tag, you can see starting from around 100 base, because this light is not working, I'm sorry for that, up to 6.4 kb. And this is from the plant. Whatever the data I am showing today here is from the plant, because deliberately we have not brought any data from the human and other sources. Just to show you with this tag, easily you can amplify starting from a smaller 100 base pair, and you can go up to 6.4 kb base pair. Now question is, as I said, we are different than others. Here, commercial 1, commercial 2, commercial 3 means all are the highly rated foreign company tag. Because I cannot name them, that's why I have written commercial 1, commercial 2, and commercial 3. You see, the activity of my tag is much, much better than anyone else. Trust me, most of the tag, they are selling around 10 rupees, 20 rupees, 30 rupees per unit. And our cost is much, much cheaper than them. Then the important thing for any enzyme is the sensitivity. Because particularly for the seed company, they don't purify the DNA. They use mostly crude sample just to save their money. They don't want to put lots of money in the isolation and other things. And then it will be difficult for you to isolate because you will be not knowing how much of template is there, what the DNA quality is there. I am assuring you with this our tag, we are getting, even though if you have a 0.3 nanogram, you will be able to get, easily you will be able to amplify. And then even any kinds of inhibitors you have in your template, it will amplify. Correct? I'm just showing a couple of seed company, like a Nirmal seed. They have used our tag and they have given a certificate. One from that side, another from Tamil Nadu side, Rasi seed. And most of the seed company today, we are in touch. We started supplying to them, and they are very happy with our products. Now coming back to another polymerase that again my team has developed recently. We call it KOD DNA polymerase. Now question is, you have already tagged DNA polymerase, why you are purifying or developing one more product that we call it KOD polymerase. So tag, as you know, so there will be no proofreading activity. So we need some enzyme where there should be a proofreading. And then there is a restriction about the tag. They can go up to 3 kb, as I said, up to 6 kb of my tag. But if you have anything more beyond 6 kb, if you want to amplify beyond 6 kb, what should be the things? For that, we have developed a KOD polymerase. KOD polymerase, our KOD is able to amplify 14 up to 16 kb. Correct? Again, how I am different from other KOD? Today, there is only one KOD in the market, that is from Twibo and sold by Sigma. Correct? Again, that mutation, whatever the genetic engineering we have done, that is different from the others. The cost for KOD in the market is 234 rupees per unit. That costly. Please, there is only one vendor worldwide today, other than us, is Twibo by Sigma, and the cost is 234 rupees for 1 unit of enzyme. We are much, much cheaper than that. And I'm showing a data where you can see up to 14 kb, we are easily amplifying. Correct? I'm showing the comparison again, and you can see Our enzyme is much better than the commercial one. You can see the activity. Hardly 0.12 unit is more than sufficient to amplify your gene of interest. Same goes with sensitivity, 0.07 nanogram. Correct? Today, isolation of DNA is a costly affair. So even if you use one column, that itself will be, cost maybe 200 and 300 bucks. With this, no need of purifying your DNA. Take your crude sample, start your PCR. Correct? Then I am coming back with the master mix. Once we have developed this product and we dealt with more of the seed company, they said, no, instead of giving me a tag or KOD, give me a master mix, where we can directly add their template or primer, they can amplify. Correct? We have developed a 2x master mix. Again, different kinds of, for the PCR inhibitor, different resistant we have added it here. It is a pre-mixed solution. No need for you to do anything. Just you add your template, add your primer, it will amplify. All the DNTP, everything is taken care by. I'm showing this master mix data from a couple of the seed company. I'm not showing their name, but these all data I received from the seed company. This is not data generated by my team with the different plants or the different kinds of site. Normally, they amplify up to 2 kb gene. You see 300 base pair, 962 kb. Similarly, 444 base pair, 1 kb, 755 base pair. Correct? So these three things directly is impacting the seed company. Whosoever here is from the seed company, please do let us know. Test our sample. If you find it is better than your old product, if it is cheaper than your old product, then please contact us. We are not going to charge you anything. We will give you a free sample where we are confident, no, it will work. Even though I am assuring you, if you find still my enzymes or my polymerase is not working for your product or your seed or your any template, do let us know. We will work on that. For that only we are a scientist. If you have any issue, you let us know, hey, your enzyme is not working for me. I'm assuring you within 7 days or 10 days, we will come up with you with the best version of master mix that will work for you. BST polymerase, I'm not sure if anybody is interested in lamp-based PCR. We have another enzyme that we call it BST DNA polymerase. Mostly the diagnostics people use. The maybe still 20% of diagnostics kit, they are based on the BST DNA polymerase. BST DNA polymerase also, I can tell you, there is only one good vendor, that is NAB. Other than NAB, there is no market for BST. There is no other vendor who is capable to do BST DNA polymerase. So there is a monopoly of NAB. We have developed a better version of BST polymerase than NAB. And this is my data. Correct? Other than that, what we call it, hot start DNA polymerase. Then again, keeping this agriculture or seed company in the mind, where they are amplifying 200, 300. One guy can set up 200 or 300 at a time. And then it was very difficult for them, because by the time they are setting 10 reactions, their PCR enzyme started working. So they used to get lots of non-specific band. So they have come up with us, hey, there is still some non-specific amplification and other things. What we have done, we have developed a hot start DNA polymerase that is again an antibody modified, where if you can put tag in the room temperature or below 60 degrees C, there will be no activity at all. You can take your time, you can keep tag for even 1 day at the room temperature, nothing will happen to this tag. And once it will go beyond 70, 75 degrees C, then only this tag will start working. So if you have anything you want to specific, you have a many sample at a time to set. You don't have any robotics and other things. If you are setting anything manually, then this enzyme will be very good for you. You can see there is a difference between if you use a hot start, your product specificity will be much better than normal conventional tag. These are our data. Once we use the tag, you see the amplification. Once we are using the hot start, it will be much better than that. Correct? Beyond that, we have a different kinds of enzyme, reverse transcriptase. Correct? I'm not going to talk more about that. I'm just discuss about a program master mix. As I said, we are working with the diagnostics also. We have our own diagnostics kit, and that master mix is entirely different than normal master mix. Correct? This master mix cost maybe 500, maybe 1,000 rupees per unit. That type of master mix we have developed. Correct? Where you can do any qPCR based work. For us, we are working on the sepsis, SCB, MCB, this type of things, where just you use this master mix, and we have our primer probe things, and within 2 hours or 3 hours, doctor can tell you you are a sepsis positive or not. Correct? Then Evergreen master mix, that is thus we have replaced the cyber green with the Evergreen, because this will be more sensitive, more stable. So normal cyber green master mix, you have a stability issue. What we did in the same master mix, we have replaced cyber green with the Evergreen. Correct? Then we have one step RT-PCR master kit. No need for you to do anything. Put your RNA, it will convert into cDNA, and then polymerase you can amplify. There will be only one tube for that. Correct? Apart from that, as I said in the earlier, we are working now related to CRISPR stuffs, and we are coming up with all Cas9 enzyme, different restriction enzyme, DNA, polymerase, ligase, that all will be good for your CRISPR things. So thank you very much for your time and attention. If you have any question, please feel free to ask me, or if we are running out of time during tea break, I'll be here. Please feel free to ask me anything.
I have a very quick question.
Please, sir.
This KOD express polymerase lab, the express polymerase, it will amplify something like 14 kb
Yes, sir.
region. Is the PCR protocol the same, or we have to alter it for?
No, program you have to make. You have to give like
Okay.
an link extension and other things that you have to decide, sir. Correct. If it is 14 kb, so I can tell you around 300, maybe around 8 to 10 minutes. If you give, it will amplify 14 kb. We are amplifying up to 24 kb. It's not 14 kb. And the beauty about that is there is no mutation. Up to why still I am showing you a 14 kb data, because till 14 kb we have not seen any mutation, sir. Correct? In general, we are able to amplify up to 24 kb. Correct? But we don't have a data for that, our own data. That's why we are not presenting. But the fact is, you can amplify up to 24 kb. Even if you take time, I was visiting ISC 2 years back, and in the biochemistry, he said, I am buying KOD polymerase. And I asked, what is the cost? And he said, around 250 rupees. A professor is a good friend of mine. I said, you give me a 15 or 20 days of time, 1/10 we will reduce the cost.
Oh.
And from there, this KOD concept came in our mind, and it entered into the journey, sir. Otherwise, there was no concept for us. We are going to.
We have this polymerase which will amplify such large chunks of DNA. QTLC can become actually very, very simple by this kind of thing. We do the QTL sequencing. Why do we do this? We can amplify this and then we can see the disease. Raja?
Can you repeat the question?
Yeah, please. I was setting question paper. Sorry.
This question you asked it. And if you have such a long stretch amplification, we can amplify the QTL region and get it sequenced.
Yes,
Much cheaper.
it's being done already. Yeah, few companies are already selling long range polymerases, and we better buy from India.
Yeah.
Particularly, they have sponsored this workshop.
Not for that. Again,
No.
keep making India concept even.
Yes.
Really understanding, sir. Yes.
I think someone should, the younger people should know the history of gene integration practice, gene, maybe 30 years ago. And it's gone through several avatars before it came to this avatar called Genie. And there was I think he's still hopefully healthy.
Yes.
His name is Dr. P. Babu. He was working in AstraZeneca, where I used to work for some time. He was the first one to release synthesizing restriction enzymes, like in the Astra laboratories. And he would take those, at that time there was no proper supply chain, including cold storage and ice boxes and all that we all have now. So he would put these small cubes of enzymes in a thermos flask with ice in it, and would bicycle to one lab to another lab to actually go to the river. But now all of us have such a wonderful service from GD and other such laboratories. I think it's easier now to get access to all the reagents and cannot do experiments. We just try to have a good protocol. So India's come a long way. So like Rajaji said, we should buy India. If you're not happy, then let them know. They'll be happy to withdraw the product, or they'll be happy to improve the product.
Yes.
Correct?
Yes.
Thank you.
Okay, thank you very much. And again, I'm taking this opportunity to express my deep sense of respect and admiration towards this organizing committee who has given us the opportunity to present. Again, I am thankful on my own behalf and on the behalf of Agri Laboratory. Thank you very much.
All right, thank you, Dr. Manish. That was really nice to know a Make in India initiative, one of the oldest companies from Bengaluru, Genie Labs, which supplies various lab reagents and stuff. So moving ahead, because we are running late by around 25-30 minutes, so we have our next speaker in the line. He's going to talk about biopesticides and biofertilizer. And since we are in the middle of UAS, so we know the importance of biopesticides and biofertilizers. Dr. Basavaraj, who is an expert in sustainable agriculture, will be joining us now. Sir, if you could please come up to the dais and raise the occasion. Thank you.
Thank you. Thank you, Dr. Jagdish, Dr. Raja, Shekhar Suman, and esteemed entrepreneurs and entrepreneurial audiences here. I don't have a PPT. You can shut down that one so that it won't pull the attention of anybody. So I have been given it 20 minutes or 15 minutes. 20? Okay. I'll do 10 minutes monologuing and another 10 minutes dialoguing. Does that work? Thank you. So the 10 minutes monologuing is going to be probably sharing my understanding of agriculture, sustainable agriculture, biofertilizers, biopesticides. That is my history. Well, of course, the wine, my wine master is here. He used to probably share the wine story also, And the other piece is what I am doing and what I am prospecting also, I will a little bit context it. The agri-tech, precision agri-fintech, all that, the next set of, initiatives we are driving at scale to bring what needs to be bought. About me, I'm an agri guy, BSc Agri, MSc Agri, PhD Agri. I totally agree for sustainable agri. Yeah, so it's been, I was also, student with entrepreneurial zeal and enthusiasm. I started Creagen LLC in US in 2007. Apparently it coincided with the date of graduation and the company registration in the year 2007. So I have come, traveled this last 16, 17 years, and Bangalore and GKVK, Dharwad Agri University have been my launching pads. When I started this concept of agri company or agri biologicals company in US, there was nothing for me. I was a student with student visa. Then I quickly relocated to India because it's a happening place here. And Dharwad Agri University gave me initial 5 years of IBT instead of agri-biotech space, where I achieved my first $1 million revenue. Then 11 years back, I relocated here in plant pathology department. There I put another company called Agri-App Technologies, because Bangalore was making some news and the noise both in agri-tech. And meanwhile, I put another, wine is also in Western world considered as a biotech. Apparently in India, it is a darudunda. There are extremities, right? So I thought I did not want to go back. So that's about me and history. I run a few hundred people team and positioning the agricultural sustainability, agri-tech, precision agri, bringing new streams of sciences, technologies to stitch the next inevitable, the business model, which helps our smallholder farmers, number one, makes food both in nutrition and calorie available and affordable as we keep, growing in population. These are big talks. Don't take it. Otherwise, you can ask very specific questions when we are going to do the dialoguing. So, Professor Sheshasai, I was a student of plant physiology. Yeah, I'm a junior research fellow in plant physiology. I went to Haryana Agri University. I as a part of this pleasure meeting you. Will catch up. So that's about my journey. I have the facility right here, and I'm also part of the Agri, the Summit BioNest here, and also we have a campus in Dodballapur, which is a Agri biofertilizer, biopesticide, INM, IPM, precision agri campus. We've been modeling different new cropping models. Basically, this is all being done But my whole idea is in Israel, in US, in Japan, South Korea, these people have been doing whatever they are doing is more advanced than what I'm doing. Let me be very frank. But what I'm remodeling and repositioning and discovering for is our Indian smallholder farmers. And that as a business model, and also bringing digital so that it could be cost effective and real time. So that's what I am trying. I had an opportunity to have this biggies in the agri space, from Dr. Borlaug to Dr. Swaminathan and Dr. S.A. Patils and R.S. Parodas. They've been encouraging and interacting. In over a period of last 2 decades, I've been had a privilege, and also I keep eating heads of Dr. Jagdish Mittur here, and many other luminaries. So this is my area of expertise. Biofertilizers, I don't want to talk much, but since my studenthood, I've been hearing the biofertilizers. It's not making any big impact, for the fact that there is a reality to it, there is a myth to it. Yeah. The reality is it can contribute to soil fertility and crop productivity to the extent of 15-20%. If anybody claims they have a magic bullet, you apply this 1 liter fertilizer and it will solve all the crop nutritional or crop soil fertility, this thing, that is a bullshit. That is crap. Okay, let's have some science playing first, and then technology coming in to help, and the commerce, taking benefit of the science. But many other people, what they say is biofertilizer will solve all the, the problems of the crop nutrition and fertility, this and that. That's all nonsense. Yeah. And there are naturally available biofertilizer, like I worked on my master's for rhizobium. It can solve up to 70%, 80% of your nitrogen fixation, only possible in legumes. Okay. In cereals and other food crops, this thing, it could go as low as even 5% also. But you can aspire for 15, 20, max 25%. Why I'm throwing this random number, it is biology. I cannot really guarantee anything, right? It's a soil, it's a microbe, it's a plant, it's the cultural practices. So it's an interplay of all these elements gives you that biofertilization. And chemical fertilizers are necessary evil or necessary devil. What I learned in plant physiology, evapotranspiration. Okay, without your, water, 90% goes in the air. 99%, I would say. So these are the biofertilizer. Biopesticide is another emerging area, right? Some of the biofertilizers, I always compare with, to make it easy for emerging, entrepreneurs or students, human nutrition and human, basically the medtech, medical industry or health industry, right? You look at that you bring an analogy, it becomes much easier for you. Right? Human nutrition. You have vegetarians to non-vegetarians to, all kind of vegans to, all kind of people like that. You have, and there is a people who eat too much of calories in the US and become so bulky they cannot walk. And then Africa, they don't have the calories to even walk up or survive. And in India we have both Americas and Africas, right? So that's and the biofertilizer and biopesticides fits in integrated nutrient management and integrated pest management. Standalone, you cannot make any one thing. Natural farming, wonderful. I say if I were to be a farmer 10,000 years back, I would have been only natural farming farmer, right? 1,000 years back, I was 100% organic farming farmer. Today, what we have to do is we have to bring principles of sustainability, optimization, precision agri, use as much as possible. Before that, you set an objective. You want to become an organic farmer? If that is possible in that crop and that place with that practices, fine. If it is agroforestry, natural farming, that's fine. But I don't want to preach as an entrepreneur and responsible citizen of this country to go organic or natural at a scale for the nation, because we will end up with producing so tiny, we will fight for the food. And that's what exactly happened in Sri Lanka. Yeah, last year I was there and I could see, a couple of guys making big decision, and the bad decisions percolate to the tiny person, people, villages. They are unable to get their portion of the meal, either produced themselves or public distribution systems. right? So coming to biofertilizer, biopesticides, I will take a few cautions. And how much time I consumed already? 6, 7, 8, 10 minutes? 10 minutes? And now I'll take 1 minute or 2 minutes and set the context of what I'm doing, what I want everybody to think if you are in agri-tech, precision agri-biotech space, right? So there's all, you can ask ChatGPT or Meta AI or anybody. It will give you all the ideas and existing problems. But how do we as entrepreneurs, how do we want to pick up one thing and solve? Yeah, that could be soil fertility, soil health, or crop productivity, or crop nutrition, nutrient density in the crop. Yeah, and anything which human basic, requirements could be met, or industrial requirements could be met. I typically call them 5F, food, fertilizer, fodder, fiber, and fuel. I'm putting together right here with a few of the folks. Can we build ethanol? I was big fan of bioethanol coming from bioenergy sources, right? So I was thinking, can we transform? Because currently, India imports somewhere 18, 19, or last year 19 lakh crore rupees crude we imported. How much? 19 lakh crore. Shekhar Sumanji, you are an AI person and biotech person interested in agri-IC, 19 lakh crore rupees. And when I was studying in agri, or 20 years back, the bioethanol industry, which contributes to our blending programs, was maybe 1 or 2 million rupees. Today it is $10 billion. Can we think of, say, $50 billion or $100 billion? I gave the presentation to Priyank Kharge, and he's insisting on putting an agri-tech center, COE for agri-tech. Yeah, I was insisting him to do in GKVK, but he's interested in doing in Kalaburgi. I'm kind of working with him and working with couple of universities to launch an agri-tech hackathon, grand challenges. Apparently, I was winner in 2018 agri-tech grand challenge by the central government. So, we need to pick 1 or 2 things at an ecosystem level or industry level. And as an entrepreneur, startups, can we pick up one problem and solve that? And there we find what we call a business opportunity. A little secret from my side. If you're an entrepreneur, you have to be like having a double engine, like 2 hearts, one for survival, one for, one for going through, another for growing through, right? So you need to have this attitude and approach for the fact that there are 130,000 startups, 4.7% are agri-tech startups, constituting more than 6,000 startups. Yeah, none of them are, not even one is unicorn. And many, 90%, not 80%, somebody was asking or telling, 90% of will not survive. Yeah, another 9% will survive with, anchoring for many these things and blessings. Only 1% will make. And on contrary, I have this a humongous data, which all of you know. Every farmer is an entrepreneur, right? Every farmer is an entrepreneur. He has land, that's his factory. He has factors of production, markets, but so innocent and nascent and untouched by technology, markets, asymmetric information, lopsided policies, which look like helping for farmer but never help. Yeah, and everybody politicizes for the. I keep telling, I'm an agri guy. I've been studying agri since '90s, mid '90s. Prioritizing farmer for prosperity, not for poverty or vote bank politics, right? That should be somewhere I think we need to evolve. So with this, what I'm distilling my current or futuristic is agri-tech, precision agri, sustainable agri, agri-tech business models, and the agri-fintech. Yeah. This country has 20 plus unicorns in agri, in fintech space, not one in agri. That's irony. Money goes where the money is, right? So it has to come to agree now. The time is to agree. As I said, I agree. All of you agree? If yes, let's pull, and as entrepreneurs, we need to look at okay, what we can actually solve the real world problems. When we look at 14, 15 crore farm families, you won't have this customer base in any industry, let me tell you. Yeah, any industry. So we have that much of entrepreneurs. Can you think about B2B, B2C, D2C, B2B to C, B2B to DC, whatever models. But you need to struggle, you need to work hard. Get ready for, if you want easy entrepreneurial opportunities in agri, please don't come. This is not for single-hearted, easygoing, wishing luck, expectant persons. It's not. You will have at least your, maybe I'll share some of the, I keep giving Pusa Krishi, some New Delhi, some insights. How do you do the generation of ideas, idea generations, startup to scale up, and what are the typical problems you come across? I have some, understanding of going through practically, been there, done that a little bit, as much as I could recollect the challenges and solve them, and I could share. So with this for agriculture, sustainable agriculture, biofertilizer, biopesticides, I think there is a plenty in agri space. And we are number 2 globally in agri, in GDP, in terms of absolute after China. Yeah, we have highest cultivable land in the world, and some of the crops least productivity. So with this, I think I set the context, and also my personal story as an entrepreneur and as a science guy. Well, that's what I'm going to stop monologuing, and let's start the dialogue. And Dr. Raja, if anybody asks a smart question, please include that in the exam question. Yeah, and if they don't ask me a question, they are not the nice. They came here for wasting their time. Fair enough. Thank you. I'll start from anyone can start from here, because we have next 10 minutes for dialogue, right? Any questions, sir, from you?
Sir, percentage of saving biopesticide compared to the agriculture chemical.
Very good question. It's not even hardly single-digit percentage. I would not belittle, but less than 1 or 2%. But there's an opportunity. Any questions? Please.
So in India, we have different types of soil. And according to the soil, the texture, the components, so different crops can grow. But when we launch a product, we launch on a single product for all the soil. So is it that way? Or do we need different type of products from different type of?
Very good question again. See, product development will have to go through multiple crops trial, multiple geographies, what we call in agriculture as agroclimatic zones. Yeah, and multiple situations or seasons. If you could pull the data, trial reports, multiple crops, multiple geographies, multiple seasons, then data will tell whether it is going to perform uniformly across the crops, region, and seasons. Then you can make recommendations. Having said, if you are repurposing existing fertilizers through precision agri, you don't need to do that. Urea works everywhere, right? Or chemical fertilizers pretty much work, but the question is efficiency, both in terms of availability and use efficiency. So you have to define your product. Whether it is a novel, innovative, needs generation of a large amount of data through trial and error, or it is existing but you are improving the formulations. So, hope I answered, sir.
Yesterday, they all learned how to do metagenomics quickly. So, and also economically, they can do it at maybe 1,500 rupees. So any given soil, they can say, what are the bacteria there? I'm asking you a business question, because if we know what bacteria is there, unnecessarily you need not supply the same bacteria. So now you can decide what it is. Is it a good business model for the students to go and start a microbiome soil testing, apart from chemical testing, as a combined model and collaborate with you, and maybe you will fund it?
Two questions, actually. See, I love this rhizosphere and philosphere. Yeah, it's like my gut, right? It's like my gut. What happens in the gut, actually, it's more important than what happens in your palate here, or what happens in the plate there, right? So it's important that we have I've been discussing only one thing with Dr. Raja for snipping and swapping, exporting some NIF A and L genes from some bugs to some bugs, and making some super bug. That's my 24 years old back imagination and experiment, actually. I worked on biological nitrogen fixation in rhizobiums, right? So I'll come to that. But his question is, can we mimic the microbiome of a fertile soil or fertile rhizosphere and profile it and recreate to all, right? If that could be done, I think that is one. I'm not an expert on microbiome, but I understand what scientific understanding and applications, and potentially leading to commercializations, right? Say, for example, there are two crops growing. I've grown sugarcane and maize beyond your imagination in India, and there are people, farmers who are growing even better than me, right? I have grown 117 metric ton of sugarcane per acre per year, and my farmer and me together are grown already 163 metric ton, and we are planning to grow 200 metric ton. You know how much of yield improvement is this over national average? 300% in my case, 400%, 500% in his case, right? I'm not kidding. And last season I got a maize which is 59 quintals per acre. National average is 15-20. Yeah. In US there is one farmer called David Hula. You can Google him. He grows 152 quintals per acre. Yeah. But can we democratize microbiome in this sugarcane, in this maize, profile it? And if you are so audacious as a student or a PhD student, I don't want to throw everybody in entrepreneurship and make you, guided unnecessarily. I came up with this concept called anchored entrepreneurship. You need to be anchored elsewhere before you achieve that financial viability. Once you get that financial viability, jump in, go chase, become millionaire, billionaire, whatnot, right? For that to happen, because there are risks out here. Yeah, there are tons of risks. So I don't want you to. That's where the safety net. We came up with IDP program in Dharwad Agri University. They gave 25 crore, I believe. I don't know. I think here also IDPs are now. I was one of the earlier guy to push and structure those IDPs. So to answer to your question, sir, yes, very much needed. Impact could be, as I said, 15, 20, 25%. Number one. Number two, you need to validate this, as this madam mentioned, for crops, soils, and seasons. Number three is, that's where the business is. Can you amplify the population of these good bugs or microbes, which contribute to either nitrogen fixation, P solubilization, K mobilization, PZPR properties, prophylactic properties? If yes, pick that bug, make that as a super bug, and make a business out of it. There are people, Pivot Bios of the world, Join Bio in US. They've been making, I don't know how much more of noise or news, but they've been doing this one for the last 10 plus years. So here, if your concoction works, or this works, we have business. But having said, it's challenging. Okay, but if you could put that together, that would be wonderful. So, sir, I don't know whether the second part I will pick later. Thank you.
Two questions from my side. First one, how farmers frequently, how fast farmers attracting to these biopesticides or biofertilizers? One, though there are chemically available, fast response to the insects, bio will take time. So farmers are attracted to this bio, one thing. Second, if I have a product of bio, any product which is showing good, how I can protect it? If I give the product to you, you can multiply that and you can.
Okay, got it. The two questions, fantastic. See, we have to understand farmer. Having the conversation by Professor Shesha Sai and Dr. Jagdish Mittur and Dr. Sharon was very enlightening, and Dr. Raja. I've been waiting for this GMO crap to be cleared for the last 15 years, right? 15 years, because I've been waiting for putting the SNF genes for decade and a half now to pick them and put them and commercialize. We've been talking for almost a year now. There is no clarity. I don't want to put money, time, effort, and showcase internal or external investors. Okay, regulatory clearance is not there, right? So, to answer to your question, see, some of the chemical fertilizers are highly subsidized. Okay, and these biofertilizers are very funny. They work, but very funny, not reproducible. They mood-based, season-based, and all of that. If you could come up with something which you can convince them, okay, use it. If it performs, they will pick it. But the rate of adoption is slow. Doubts are many. Adoption is slow. So you have to have that patience and persistence both. Number one. Number two, you have to understand this very economically challenging bottom of the pyramid customer base, BFC. Remember, everybody, it's very important mantra for any startups. It has to be better, it has to be faster, it has to be cheaper in price, not in the value, right? BFC. If your product has this BFC, it has to be better, it has to be faster and cheaper. Adoption rate could be enhanced. If it doesn't carry that, well, you will have a slow death or a slow adoption, right? So next question, there are various ways of protecting your organisms, formulation or technology, right? You could use patenting or registration of the microbes, this or that. So those are the one or two. More than that, I may not be able to give. Dr. Jagdish or the panel will give. Next question, please. What time out? See, I like this session rather than the monologue.
Sir, what are the registrations or the certificates one should have to start any biofertilizers or biopesticides?
Good question. There are two sections. Biofertilizers is easy to get license, permissions, and get into the sales. Biopesticides is less challenging. Okay. Biofertilizer, all you have to take is go to any state, get the license of manufacturing and marketing, and you're good. And you comply the quality standards of the particular state as per the FCO. Biopesticides, we have to have central government registration and then state government licensing. And it is the same in US, even more complicated in US. India is much sorted in biofertilizers and biopesticides.
Great question for the question.
Absolutely. That's if there are no questions, please.
You have mentioned about rhizosphere and phytosphere. There is another area, endosphere, end of rice.
Yes.
You are considering that?
We'll go one step at a time. If I talk about anybody here, I'm going to get into your gut or veins, they would scare you.
The understanding is that inside of the plant is so full of microbes.
Very true.
Which are much more than even the
if we manage this too, I think we are going to, of course, this sugarcane has this endophyte, gluconacidobacter, which does.
Not just that one. There are mostly uncultivated form. And the information is that the microbes, the seeds are coming packaged with a series of microbes which are inherited vertically. So that also, I think most of these biofertilizers or biopesticides, they're not taking the approach the endosphere part. So that is what
I know that theoretically as a science guy, but I haven't seen any commercial or R&D based products as of today. So exciting to explore. We leave it to youngsters who are, can explore. With this, I think if there are no comments or if you have any questions, I continue to ask me, via the platform here or message me, more than happy to answer. Thank you very much, Sekhar. I took a couple of minutes extra. Yeah, much appreciated. Thank you.
So I must say that was really insightful. And each time I walk past KFC, I remember his BFC mantra. Even though I rarely go to KFC, but each time I look at KFC, I remember BFC. Better, faster, cheaper. Then only you survive and get the adoption right. So great mentor and great knowledge giver, Dr. Basavaraj. Thank you so much. Lovely talk there. We are running out of time. We have now a panel discussion before we break out for the tea. On agriculture for beverages, challenges and opportunities for farmers, startups, and MSMEs. This panel will be moderated by my very own mentor, Dr. Jagdish Mittur, President of IBIOM. Panelists will be Dr. Gajanana from Rico Vineyards and Wineries, Dr. Kashif Sharif from Mercury Biotechnologies, Dr. Pius Thomas from Thomas Biotech, and Mr. Senthil Kumar from GPS Institute of Agricultural Management. I'd request the organizing team if they could help us with the chairs on the dais. Yes, so I think 5, yes. So while we set up the chairs, how many of you love beverages? And what type? The cold or a hot or hard or soft? Anyone for cold? Or hot beverages? Coffee drinkers? Do you like coffee? Okay, awesome. So our panelists are ready to discuss on agriculture for beverages. Over to you, sir.
Switch the
Lights.
Thank you, Shekhar. Nice to be here. Great to see so many people in the room still interested in the panel discussion. Great talks by the previous speakers, Dr. Girinawar, Dr. Manish Thakur. Thank you so much for introducing Bangalore Genie, or Genie now. And prior to that, which was the other talk? Oh, Dr. Sharanangadi, I'm so sorry. All the readers, I'm losing memory here. So I'll continue the questions that Shekhar was asking you all. So which is the, I'll ask you a question. Maybe Raja can take on the questions if he wants to answer them again. But there's a very simple elementary questions. So which are the fruits that we source for beverages? Grapes is one. Okay, grapes is done. And we have a person representing grapes, Mr. Gajanan Bacharya. Please come have a seat. Please come. Please give him a hand. He's our wine master. And he works in the company that Dr. Basavaraj Girinawar started. It's called Rico Wineries and Vineyards. He's in Singanakanalli on the way to Rajankutte. You just have to cross a train line, make a 45-degree left turn. About 1 kilometer, you have a beautiful winery. I think they can hear me, Raja. Okay. So there, he is the wine master. He makes, and Rico, under the guidance of Dr. Girinawar, makes one of the best wines, as far as I know, in India. And they've even won awards nationally, internationally, particularly 2015. No, that was the recent one? 2022, they won a bronze medal in London when multiple 36 countries were putting out their wine in London. So that's pretty good. And the interesting thing is the vision that I call him Basu, I call him BG. BG has from his graduate days, postgraduate days, and then definitely precipitated when he was, and then he said, you should come back and help the farmers. On one side, you have people like us who savor the wine. On the other side, we have farmers who depend on their produce, which is grapes. So that's grapes for you. And then, okay, after grapes, any other fruits?
Passion fruit, oranges.
Papaya. Okay, papaya. I'll just pick, okay? Okay, give others a chance too. Papaya, we have Dr. Pius Thomas from Thomas Biotech. Please come. So we have papaya represented here. And papaya is a very, very healthy drink. I'm sure he will give you a little bit of a discussion on that, and very, very exciting drink for all the wonderful things that papaya has. He's even got some products. I think he's put them on the desk as well, outside for you to taste and even to buy if you want. Some amazing papaya drinks. And his company is called Thomas Biotech in Jakur. Jakur? Amruthalli. So, but I don't know, papaya is right now being used for soft beverages. Okay, whether it's Gajan is going to talk to him to make it to hard beverages, I don't know that.
Why is also soft? Why it's a soft beverage, is it? It's like doesn't come under the hot kind of things.
Alcohol.
That's
Alcohol.
It's
very wine.
medicinal basis wine actually.
That's because you got used to bigger drinks.
Yeah.
So it all depends on the perception, on the body capacity of the body, how to metabolize your alcohol. Okay. Okay. Next fruit. Banana. Sorry, we don't have represent banana here. Pineapple. Okay. Pineapple again. Again, the visionary of Dr. Giranawar. Amazing. He said we can make wine out of grapes, which is white grapes, black grapes. We can also make wine out of pineapple because pineapple farmers are plenty in central part of Karnataka, north part of Karnataka. So they make Rico makes wonderful pineapple wine, which is highly suitable for Indian palate because we eat hot food. Okay, hot food, this goes really well. I know people with the drink they almost think it's a juice, pineapple juice. But after some time, kikkodi starts. So pineapple juice is very, very popular thanks to the winemaker. He's amazing. Okay, next fruit. Pomegranate. They're experimenting on pomegranate as well. And Thomas Biotech also has products from pomegranate. Okay, and then what about any other, not necessarily fruits, grains? Millets, and then barley, wheat. Yeah, barley, wheat, rice. We have beer and whiskey and all that made, and we have Dr. Senthil Kumar. Please come. He's a senior person. He's going to talk about how Agri-Biotech can help for production of grains and how that can be converted to not only to help farmers but also to big heavy consumers of what products that comes out of barley and then. Okay, then who does I have? Okay, there's one other, yes, two other, okay? Okay, so I think Dr. Giranawar discussed bioethanol, right? You said something about bioethanol? Okay, ethanol is, we always looked up to sugarcane and other crops to see how we can reduce the exchequer expenses on petrol and diesel and all that. So sugarcane was the source crop for extracting ethanol. And we have Dr. Virendra Patil, who, he's here, please come. And a special thanks to him. One more round of very big applause because just at my short request, just about 5 days ago, he traveled all the way from Bidar overnight to be here at 8 o'clock this morning here. So thank you, VP. I call him VP, Virendra Patil. Let's I'll stand here.
You don't want to sit?
I don't want to sit.
Okay.
Okay, now
You will sit or you stand there and talk. What's it?
no, they're going to sit. I'm going to sit. We need some extra mics though.
Why you try all that?
Only one there, right?
Somebody has stuck it in this.
Only one mic.
Whichever one is.
Oh, that one? Okay, that's fine. That's fine. You can just pass it on.
Hello.
Oh, that's why they have stuck this here. Yeah, that's the one. Can I take it out of this?
Like that.
Yeah.
Can you preach?
Yes.
Okay.
Where does it reach?
Okay, one more introduction. You please, Rajaji, this is one more question for you. Please source another substrate, if that's the right scientific word, to make wine or a wine-like product. Another source, which is getting very popular in India. Cashew. I tried to call someone from Goa, but no one accepted my thing. Next time around, go cashew, fenny.
Honey, sir.
Honey, who said that, honey? Oh, you're not qualified as well. Okay, we have a very young man called Mr. Kashif Sharif, and he's very much interested in sourcing honey from different kinds of source flowers from which the bees suck nectar out. And then the honey that's on the wine, it's called mead, M-E-A-D, mead. That's a new kind of thing. So he's very good at that. So we'll have some questions to ask him also. So Kashif, please give me. Okay, just to set the tone, like all of the crops, these fruit-bearing crops or cereals, which are the source for beverages, both hot and soft beverages, also have challenges like your other regular crops have. Be it pests, be it other diseases, be it drought, be it whatever. I like the way Shesha is orchestrating the lights here.
He's putting us in limelight.
In limelight.
Tell the fan the same.
So So they also face challenges, right? And they've been very engaged using traditional methods for breeding, for coming up with all the other magic for the crops to grow in a better way, in a more productive way. But with the advent of technologies that you heard since yesterday and how you can use them. So my question to them will be, what are the challenges, opportunities they have in each one of these crops or source products from which they source substrates for making fermenting, for the drink that they make. Of course, Dr. Thomas is not into that. He's only meant to straightforward into breakfast drinks or soft beverages. Okay, so my question. Okay, anyone can start. Okay, my question to you is, what is your knowledge in using Agri-BT, agri-biotechnology, and other technologies to better your source crops? I'm sure all your source crops are also face the challenge of pest diseases, not enough water, soil content, microbiome, and things like that. So what is your knowledge of using Agri-BT? Has it been used, or is there opportunity for companies like Genotypic and Genomics and even universities with whom you can collaborate to make those better crops? Anyone can go. Raise your hand. You want to go?
Yes, sir.
Sure. And keep that also, please.
Maybe you
okay,
keep
stay.
this with you.
सर सबसे एक रिक्वेस्ट करना चाहता हूँ कि मैं जो भी कन्वर्सेशन है हिंदी में करूँगा, मुझे इजी होगा, और जो भी अंडरस्टैंडिंग है, जो भी मेरा नॉलेज है, मैं आपसे शेयर करूँगा.
One second. Does everyone understand Hindi? No? Oh, we will try and okay. Go ahead.
डेफिनेटली जैसे कि आपने क्वेश्चंस किया है, तो डेफिनेटली फार्मर को बहुत सारे चैलेंजेस है, पर अगर हम जीन्स ट्रांसमिशन जैसे कि जीओएम से अगर हम करते हैं, तो उसके डेफिनेटली बेनिफिट इंडस्ट्री को है और उसके साथ ही फार्मर को. एग्जाम्पल के साथ अगर बोलना चाहूँगा तो कैबरने शिराज, जो कैबरने और शिराज का मिक्स वैराइटल्स है, जो अपने इंडिया में सबसे ज़्यादा पॉपुलर वाइन है. अगर उसको हम सही तरह से प्लांट में ही जीन्स ट्रांसमिशन करके अगर वही वैराइटल्स हम कन्वर्ट कर सकते हैं, तो एक बेस्ट अपॉर्चुनिटी है इंडस्ट्री के लिए और फार्मर के लिए. एक हुआ. दूसरा जो है कि कुछ एरियाज है जो इंडिया में अभी भी वहाँ पे वाटर का फैसिलिटीज नहीं है, पर समर टाइम में ज़्यादा डिफिकल्टीज होता है. जनरली 8 मंथ वाटर फैसिलिटी रहेगा, पर 4 मंथ स्पेशली 2 डिफिकल्ट मंथ जो है समर के 2 लास्ट के डिफिकल्ट मंथ है. तो उसमें अगर हम वैरायटी जो भी जीनोमिक्स के साथ वर्क करके अगर वो वैराइटल्स को हम फार्मर को अच्छी तरह से मीन्स एक्सप्लेन करके अगर वो वैराइटल वहाँ ग्रो करते हैं, जैसे कि कैबरने जो वैराइटल्स है वो अगर जो ड्राई एरियाज है वहाँ पे हम ग्रो करते हैं, तो उसका बेनिफिट फार्मर को तो इनडायरेक्टली है ये, और वो इसीलिए क्योंकि ये जो वैराइटल्स है ये फ्रेंच है, इंडियन वैराइटल्स नहीं है, पर हम जीनोमिक के साथ ये इंडिया में अच्छी तरह से ग्रो कर सकते हैं, जो ऑलरेडी डॉक्टर बसवराज सर उनके विलेज में ये कर चुके हैं. तो उसका रिजल्ट ये है कि जो फार्मर की जो स्टार्टिंग कंडीशन मीन्स 2008 में वहाँ पे वाटर का अवेलेबिलिटी सोर्सेज बहुत कम थे, पर जैसे ही इंडिया डेवलप होने लगा तो 2 साइड से 2 डैम्स और सह्याद्री हिल्स, गुड सॉइल, गुड टरवार अवेलेबिलिटी होने के बाद डॉक्टर बसवराज सर ने वहाँ पे फर्स्ट फ्रेंच वैराइटल ग्रेप्स ग्रो करना स्टार्ट किया. आज का वो विलेज का सिचुएशन ये है कि वहाँ पे 210 एकर्स फ्रेंच वैराइटल ग्रेप्स है, तो वो फार्मर है, और उसकी वजह से ही आज मेरा रिको स्टैंड है. क्योंकि अगर हम कंपैरिजन करते हैं अदर इंडस्ट्री से, हर एक इंडस्ट्री के पास इंपोर्टेड कैबरनेट वैराइटल्स है, हर इंडिया में हर जगह पे वो ग्रो हो रहे हैं, जैसे कि सूला है, फ्रेटेली है, ग्रोअर्स है और हम है. इंडिया में नियरली अबाउट 128 इंडस्ट्रीज है, पर उसमें सस्टेबल अभी तक है वो 4 या 5 इंडस्ट्रीज. उसका मेन रीजन है ग्रेप्स, पर वहाँ पे भी चैलेंजेस तो हर एक को फेस करना ही है. वो चैलेंजेस लेके ही वैराइटल अगर हम ग्रो करते हैं, जैसे कि कैबरने सूला का कैबरने ब्रांड है, फ्रेटेली का है, ग्रोअर का है, और उसके साथ ही रिको का है। पर अगर हम जीनोमिक से वर्क करते हैं तो उसमें स्पेशल कैरेक्टर डाल सकते हैं। जैसे कि ब्रांडिंग के टाइम ही समझो अभी 4 बॉटल कैबरनेट हर एक इंडस्ट्री का है, पर उसमें रिको का कौन सा बॉटल है, अगर सेम टेस्ट रहेगा सभी का तो आपको पहचानने में नहीं आएगा, पर अगर वो टेस्ट में ही डिफरेंस रहेगा तो आप इजीली बोल सकते हैं कि ये रिको है। तो ये जो है ये हम जीनोमिक से कर सकते हैं सर।
All right. So,
Yes, sir.
so
Thank you.
basically, what you're saying is that since there are so many different varieties based on which your drink is actually labeled, Cabernet Sauvignon, or Pinot Noir, and so on, you would rather have better characteristics. No, I think he can hear. Can you all hear me? I have this one. So, okay. So basically, what you're saying, if I can translate it properly, my Hindi is not so good. He's saying is that if we can, at the genomics level, if we can characterize these two different varieties or many different varieties of grapes, let's say Cabernet Sauvignon as an example that you have taken, or Pinot Noir as an example, from French varieties, Indian varieties, other varieties, you will be able to better make it more precise if you want.
Yes.
Okay, because some of the wine tasters may say that your Shiraz is very, very good, but there is something that is missing that I get in French wine.
Yes.
So will you be able to, through QTL technology, will you be able to introduce that?
Yes.
That's your thing.
Yes.
Okay, thank you so much. So who's next?
Can you have a question now?
Or later? Later, I think. Just write it down. Okay, otherwise it will go on to forever. VP, you want to take the floor? So Dr. Thomas is representing papaya and what he's trying to do with papaya.
Yeah, I was inspecting ICR service for about 30 years. I opted out on VRS, and my interest initially was to take tissue culture papaya as a popular one, because we know male, female, hermaphrodites, different sex forms are there in papaya, and we usually imported all the seeds from Taiwan of a particular variety, Red Lady. So whether there could be a substitute, so that is the reason I came to this line. And I started with papaya tissue culture. First thing is we wanted to have a elite type. So we went for selection and made one female elite plant type, which is called Dawn Delight, which gives dwarf plants with the seedless fruits. The fruits are there on display. And another one which is giving relatively big size fruits, about 2 kg, oblong fruits with seeds, which are very good for distant transportation. Both these types are on display there. And I experienced all the tissue culture papaya was a very good proposal, and a lot of work has been done world over. I know you are one of the panel initially in the project also. And I found extremely difficulty in executing the project. The main difficulty was the reproducible tissue culture protocol in papaya, particularly because of the interference from microorganisms. That is where I entered the area of endophytic microbiology, and I found inside of papaya is so full of microorganisms, which are including both bacteria and fungi. So since I got stuck with that tissue culture, my original plan, and in the meantime, the farmers also used to be coming with the issue that the papaya, although we pay about 40 rupees, 50 rupees the market, what the farmers get at the farm gate is all about 10 rupees or 12 rupees. So there is a wide gap. And also, papaya is a very highly perishable fruit. We cannot keep for a long time. And the market, there are no products available based on papaya as such. I don't think anything is available except as commodity of mixed fruit juice or mixed jam. Then we started this effort initially to develop a jam based on papaya. We came out with one product called papaya honey jam. Then we started hearing this is having sugar. Then we came with a counterpart without sugar. It's a diabetic friendly jam. Then the question was, now is it possible to develop a drink based on papaya? And initial efforts, after a lot of R&D, we came out with one product. It's a papaya lemonade delight. It is papaya plus lemon combined. It's a concentrate which is to be diluted. And then again the question whether there is something suitable for diabetic people. So we got a base formulation, diabetic friendly formulation with stevia sweetening, and different other combinations with the passion fruit. This is another combination. So these are the aspect, this is where I entered the beverages area. So it was not an intentional one, but then based on the requirements, and we felt there is a requirement for both my requirement firstly, then the farmer's requirement, then a new product which is healthy and acceptable for the customers, because there is no, as I mentioned, no product in papaya market. So then the question was like, now these are to be formulated or diluted. So is there a way of having a direct consumable drink? So we came out with first one product. It's called papaya nectar, which is just R&D is kind of completed. So this is something equivalent to mango maza or fruity equivalent, and again a counterpart of that one for diabetic people, without sugar. So like that, these are the 5 categories which we have come out with beverages, which is a big challenge for papaya, because papaya is a very bland fruit. Usually all the fruits which are considered for processing, mango, orange, they are sweet acidic. But papaya is a very bland one. Secondly, it's a highly vulnerable to microbial damage. So then we developed a series of other products. Maybe later
come to that. So thank you, Pius. But keep thinking of how the technologies can help. I think you've done a very good job in terms of what was available to you. You've converted into products, and you may have challenge in scaling them up. And you've already popularizing many products. But what challenges, that you have, papaya growers have, okay, and that you can help them to collaborate with companies, startup companies, or with the departments like here, for you to get a better access to good crops. It could be something resistant to papaya ring spot virus and many other diseases that you have, or making it more more shelf storage thing, okay, less perishable and so on. So keep thinking about that, okay. So Senthil, you would like to?
Thanks. So good evening, everyone. I'm Dr. Senthil.
Kashif, you come here.
Alumnus of this institute, PhD from Agriculture Microbiology. So basically, we are working as a system like entrepreneurs and research. It will directly hit the market. So I'm working with a company, with an institute which is sponsored by Multiplex Fertilizer Company, where we are engaging PUC students for research and PhD people for marketing. That's what the thing is that. So what we are doing is, finally, the journey started like this, because PhD students are better in explaining the things, and PUC students are very disciplined doing the research. That's what we want. And with that, actually, we got a couple of the patents too, and our products hit the market only 5 years before. Around 5 to 6 crores we are making a business every year. Okay, anyway, I'll come back to this serials. The story started with the ragi. So we are having around 50 acres of land in and around Nelamangala. Of course, we are going to be very rich if the airport is coming there.
Awesome. You think?
So this 50 acres actually is coming under dry land, and we are growing every year ragi. But unfortunately, the market for ragi, the better prices are not there. So what we thought that is actually better to convert it into the processed foods, then we converted it into the flour, so many things there, but a lot of competition. So now we have entered in another area where an alcoholic drink from ragi, because once you add alcohol, then more value will be there, wherever it is. So we have thought about it then basic research you have done. Your fermentation has to be carried initially by yeast, later by LAB, lactic acid bacteria. Essentially, where big fermentation scientists are there. I'm not good, but anyway, we started with that. So initially we started with a kind of a yeast which can degrade these complex polymers into simple sugars. Then LAB, where we worked PhD people that we engaged a couple of my PhD students to find a right LAB so that the aroma of the product should be good. So that's what and it's going on, and the results are very good. I have a couple of PhD students. I always ask them to work for the products rather than basic sciences, because the people needs the products. That's what it is essential for it. So now, this is one way, but during this process, actually, we found a lot of difficulty in growing of ragi crops because of this water scarcity and so many issues are there. Though drought-tolerant varieties are available with the universities and all those things, that For the last 7 years, we are saying that in field, the performance is not much to that level. So what we have done is actually, I belongs to Rameshwaram, where actually I've gone to my native place. That at the time there was a discussion about that. This is happening, that is happening, that. My Aji was telling that, I mean, he is contributing for the research in some other way. He's telling that, I can tell in Tamil if you can understand. Mulla that is that, what is that? You have to use the spine to take out the spine. If you
Oh, yeah.
Okay.
Thorn out of a thorn.
Exactly. So we got an idea that with this, I'll come back to this again. We worked a little bit with the papaya with this knowledge actually. We have started working on a small batches of stickers that is stuck on the apples. You can see that the stickers there. So we have worked on the stickers where the stickers are from microbial metabolites. Maybe acetonitolite, I can disclose it then, which this nitolite can prevent this ethylene action on the fruit ripening that. So with that, actually, we have initially started with the banana and with one sticker, and we have delayed the process for more than 3 to 4 weeks. A banana can be transported well. So it is like it is working very well. Now it has gone up to 6 weeks or 8 weeks. The products are getting ready, maybe hit the market soon. So that concept where it is that we have taken a soil microflora and injected with ethylene gas. And the soil is injected with ethylene gas. And because of the ethylene gas, the microorganism produces anti-ethylene compounds to neutralize. And those compounds we segregated and we used it for the anti-ripening process.
So they're put in a box or in a big crate?
In a box. It's soil containing box. Soil will be at the bottom. There are the microorganisms. Maybe we are having a different ideas to sell it for in the homes that you can delay the ripening of any fruits. Of course, it is ethylene that. Any fruits that, a box that. This is how the entrepreneurs are working with us that. So we have given to that entrepreneur model now that is working on that. This is the second. And third one is related to the ragi wine. It cannot be called as a wine, but
ragi malt.
Ragi malt or whatever it may be. But the aroma and the flavor has to be increased with LAB, lactic acid, group of bacteria. That we are using a lot of molecular tools, including metagenomics tools or something like that. That I have given to the PhD students to some extent, and the PhD helping them in getting these laboratory experiments, and things are going on. Good. So this is where we are into that research and entrepreneurship.
All right. So one of the comments I wish to make, and also something you need to think about coming from GPS, is that since you're in this panel, you're presenting grains like ragi and wheat and barley and so on. India is really getting its name put in the world whiskey map, Scotch map. Amrut distilleries, that won the prize. That's amazing. We usually attach Scotch and whiskey to Scotland and countries like that, but India is really making a big mark on that. So think about in supply chain. Are you, whoever it is, you may not know now, you can do research on that. Are they getting enough good quality barley, good quality wheat? From the brewing point of view, from fermenting point of view, what challenges those grains that you get have? So that's something also think of. The whole idea of this panel is to see how we can connect you to the real researchers, the real R&D labs, and connecting to the market later on and so on. So keep thinking about that. Okay. Now this guy, Mr. Kashif Sharif, you heard of the song "Money, Money, Money is a Rich Man's World"?
Boney.
Not Boney M. ABBA. This guy sings "Honey, Honey, Honey." Okay, on to you. Go ahead.
Hi. As Mittur sir's introduction, I mainly deal with honey. So in and out of honey, everywhere about honey. But here the application is more, or the question was more that how do you use agri-biotech for beverages? But I'm going to deviate a little bit, and I'm going to target directly at the bees itself, because more than the honey, our agri-biotech has to focus on the bees. And agri-biotech as such in India for the bees is very overlooked, or we don't give enough importance, though they are the most well-known pollinators across the world. and we say that, oh, the bees are in danger. If the bees goes away, then our all our crops will go, cash crops will go, everything will go. And yet we as Indians take everything for granted. That is one very sad thing that also happens with honey also. We take honey for granted. It has so many benefits and so much goodness in it, but we take it for granted. For example, I can give you a bottle of honey. You will have it after a year. It'll still be there with a little leftover in the bottom of the bottle. So we don't appreciate honey, though it has so much of goodness. But coming to the agri-biotech side of it, so a lot of research has been done by the West, especially into honeybees, where they have tried to introduce honeybees or hybridize honeybees to match different climatic conditions and everything. For example, if I take the Indian honeybee, so the actual Indian one is the Apis indica, but then you have a species that is called Mellifera, but it's actually an Italian species that has been changed, or it has been actually uh, adapted to the Indian temperate climatic conditions and everything. So why are we doing it? So that is the another question. So why do you have to hybridize bees, or why do you have to adapt bees or acclimatize bees for any given condition? So for example, if I take the Indian honeybees, they have a lot of disadvantages. One, they're very aggressive. Two, they're very hard to maintain because they have this particular characteristic or trait called absconding. So what they do is, you put too much tension or pressure, they will run away from there, just like that. So they'll abscond, they'll go on a tree and they'll build over there just to show that, see, we can build here and we can sustain, we don't need you. So that's another problem. But when you take the Italian bees, they're really resilient to a lot of things. So the most famous was, recently there was a fire in the church of Notre Dame. So what happened? Huge fire, the whole church was burning down and everything, they were trying to put it down. So these guys are one of the oldest beekeepers that are there. They have an entire, the roof is filled with honeybee colonies. The whole fire gutted the colonies and none of the bees flew away. So they just stayed till their death actually. So that is their resilience that those bees have. So that's why this was bought in here, so that we don't have to rely on the Indian honeybees. But again, the problem with the Indian honeybees is they're much more smaller in size. Their colony sizes are smaller. So what happens is your yield is lesser. So I get these bees, that is the Italian bees, and they give me a much higher yield. For example, the Indian honeybee yield is around 5 to 6 kgs in a season, but the Italian ones are nearly 10 to 20 kgs in a season. So this way, hybridization and this thing brings in a different type of honeybee. For example, one of the best known is the variant of Cuba, a small little country that is there. So they have a variant of bees which are very resistant. So there's another disease that is happening called the Varroa mite disease that is happening. So again, this is another trait that we are not looking at all, but the entire West is working on it. Luckily for us, most of our bees are not affected by it, but it's only a matter of time. So it will happen, but we are not ready for it. But the West is fighting against all of these foul brood disease, and there are a lot of diseases that happen to bees which we don't focus on. But then finally, when I come down to the Cuba one, so they are very resistant to this Varroa disease, that the bees itself have a, what do you say, a trait where they will go, they will clean a colony, remove the mites, and they will clean. So it's called Varroa sensitive hygiene trait. So the bees have a trait to search for the mites, remove it, and this thing. Can we introduce that into
Jagdish was asking a question to begin with, that are there any, have you used technologies in? So I know one example which I would like to share. In fact, he's my student and he's working in a USA dry land genetics. That's from your university. And they concentrate on prosomillet. So I was discussing with some people this morning. This in India we're not good in exploiting whatever we have discovered, or we're not very keen on economically exploitations. But in US you find that very much. I think they're very good at it. So I really appreciate that US atmosphere, and hopefully gradually it has come to other sectors. But coming in agri sector, I think it is also coming, and hope comes sooner. His professor made a mistake. He completed an experiment. He forgot to dismantle everything, and one plant was growing very well. And even after 4 weeks, no water was given. Still, it was standing going. From there, they started. So then, what they have done is they collected several prosomillets and they did the whole genomics, and they found out the variations, and they conducted wide crossing or something. I'm not very familiar. Then from that they have picked up varieties. They have come out with 2, and they say they can grow prosomillet up to 20 quintals per acre in an area where less than 100 millimeter rainfall is coming. They say if we plant corn in there, hardly it will germinate and maybe grow a feet tall. So that's there. And also interestingly, I was telling that Sharon Angadu was saying only tools are not done, basic this thing. From that also, the climate also plays a very, very important role. The same varieties which are not performing okay, or 2 to 3 times more yield, they have put it in Guatemala, where he said the increase in yield is 5-fold. So whoever does this large scale commercialized other things, they have to really look for where it really will. Personally, I know that the Bengal gram yield in my area is just 4 to 5 quintals per acre. Whereas if you go to Gulbarga district, some areas it is 8 to 10 is their common. So climate does play a very important role. I don't know how you really connect. Let's finish up. Yeah. That's it. Maybe Sweet Sorghum, I would like to say something maybe later if there's an occasion.
Okay, so thank you. So all of you got a feel for the challenges that exist in all the crops that each one of them discussed, including honeybees. So now I would like to pose a challenge. This is a situation where there are 2 entities interacting with each other. Your source carbohydrates as a substrate, and then a microorganism, which is your fermenter, pretty much, okay? Whether it's any production systems that you have. So if there is one suggestion that you would like to make to the audience here, and to the genomic technology experts here, how would you like to use your genomic technology to improve something in a specific situation? So just one comment very quickly, and then we will wrap it up with a few questions from the audience. Okay, who would like to go first? You want to do? So what is that one thing that you think that Shesha and many other people can help you with?
1 or 2 points I would mention is very important. One is like papaya is very vulnerable to papaya ring spot virus, which is a world problem. Anywhere in the country, you find all the plants with wrinkled leaves, and this is a typical fruit coming from a plant. And if this is from a plant which probably got the infection at a much later stage. If the infection is happening at an early stage,
you won't get that.
You won't be having the properly. So after investing so much, so we don't have any varieties which are resistant to the papaya ring spot virus, and there is no source of resistance in the species. Our intergeneric process were attempted at IIHR, which didn't succeed. Now, the only way forward is through transgenic approach as of now, which has been very successfully demonstrated in the US. You can imagine a crop, you don't get any crop at all, or you harvest about 5 tons per acre compared to about 50 tons per acre. Which is since we are not having access to the GM technology, or it's not possible to do that work. We are now growing the crop under protected cultivation, and those fruits are displayed there, which are, instead of these fruits, they are very good in size, yield, quality, and every parameters, which are very much suitable or required for the any kind of processed products, besides giving the support to the farmers. This is one aspect. Two varieties are there which are common in the which have saved papaya cultivation in the US, Sun Up and Rainbow. This is very popular in the US and it's a success story. Second one is about marker assisted selection of, particularly one is for disease resistance, second is for sex marker. I told there are different male, female hermaphrodite plants in papaya. We get to know about the sex form of the papaya only after about 4 to 5 months when it comes to flowering. So if it is a male population, which is not at all required. So always there is a preference for hermaphrodite plants which are giving fleshy, long or big size fruits. So which is very much important. There is also technology already available which you have made use of in this particular selection of both dawn delight and Tom's delight for identifying at the early stage hermaphrodite and female plants.
Are you collaborating with anyone in the department, in GKVK or elsewhere?
Right now, we would be very much interested in the GM part, which is not going to be fruitful. But the other one is we are able to do it ourselves.
So my immediate suggestion is all of you who feel that you're constrained because you cannot use certain technologies, I think we should put together, maybe through IBIOM, a paper. Whether they address it or not, we don't know, but we call it be in it to win it, right? So let's prepare a document for all of you who have had this frustration of not being able to use a technology which are available elsewhere. So quickly, one question too. I know you had a lot of crops you mentioned. If there is one crop that you wish for the technologists to come and help it, which crop would that be, and how would you like that help to be provided?
As I said, for bioethanol, sugarcane is the preferred crop. But however, it has its own constraints.
We know that Creagen is doing a very, very important project called Smart Cane Project. So you need to talk to him about how he can.
Sure. The crops I have evaluated and I have done some kind of imagineering is these fodder crops. Fodder crops, although already they are rich in cellulosic material, plus there are some like sweet sorghum. They already that sugar producing machinery is there.
It's already there.
And with biotech tools, whatever is available, can we enhance the sugar content in that? And plus, in addition to that, multi-crop is another, multi-cut is another character which is required. So when I was working for Praj Industries, we did some small this thing. We crossed sweet sorghum with sorghum Sudan grass, and we were able to get multi-cut sweet sorghum. That was one of the good things we had done. And the other one thing I would like to is that look at bajra. Bajra is also very I was mentioning about different crops. I mean, characters of ideal biofuels was you should come up in marginal crops, multi-cut. Bajra is very ideal. And fortunately, like sweet sorghum, there is sweet bajra also, but people have not looked into it. Okay, I would like to tell that at ICRISAT they have 12,000 collections of bajra lines. I think nobody has looked at it from this angle. That would be very nice.
Thank you. Let's talk to Gajanan. I know that you use a lot of strains, Cerevisiae strains, and perhaps similar ones for your specific fermenting of a certain kind of substrates, right? So what is that you think we can do, technologists can do to help you and to help the industry grow better?
Already a lot of research is going on there because of especially France and Spain. These two countries, lot of research. Every year they launch the new yeast, especially yeast strains. Like Saccharomyces cerevisiae base, but remaining lot of yeast now is they develop like Iperni, QA10, QA11, EC11118, L226. But still their scope is there. If means particularly one industry, means example RICO. So if you RICO want to best product, so again we need to focus, means particularly Shiraz. So if you differentiate with the others, that time if you work in with the help of Agri-Genomics, and we create the special strength for specially Shiraz purpose. So definitely we improve, means This Shiraz is world best. How Rico Shiraz is world best? Easily identify to all my best customers.
I see. Okay, so you'd be looking into that in case you want some collaboration to happen through the founder CEO of the company with any East laboratories who can breed or can generate such strains.
Actually, you is the best person for me.
Not anymore. Not anymore.
Because of already you done a lot of research in the East.
40 years ago.
No, but still, you young sir. Sorry,
I can be a mentor.
Yeah, sir.
Senthil, please.
We strongly believe that the future market, especially lies in the future market, money and challenges lies in climate change, logistics, and value addition. We have taken it as a priority that. So when we talk about the climate change, actually, we need really a crops which can adopt for climatic conditions. But we are not ready to disturb the plants because let them do that. But we will, as Dr. Basavaraj rightly says that we won't have a philo microbiome. So if the technology helped us for each and every crop, initially work has started, but for the staple foods, it has been ignored mainly. So remember, the 50% of the food is from cereals, mostly.
Yes.
And the 60% of the cereals are produced from the dryland area. And if the climate changes, then there's a drastic problem with this. So people would not understand. Even 1 degree increase will affect 54% of the yield. That's what the researchers are saying that. So we are suffering a lot. So in this condition, then the best advantage, the best solution is with the microbiomes, tentatively, especially that, because unnecessarily interfering in the genetic constituents leads to a lot of complications, especially what is happening in India. So better to go with the philo microbiome concepts. Do better genomics specs, have a map, and also it's not a philo organism. Dr. Paes was told that endo microorganisms. Endosphere microorganism and rhizosphere. Rhizosphere is somewhat well studied, but the philosphere and endospheres are actually not given. So in that, we need the support of the technology. And especially in terms of the cereals, because they are depending upon whether it's the pizza or samosa or whatever it may be, the first thing is cereals, then comes the vegetables.
Thank you so much. So last but not least, so Kashif, I didn't know that honey had pollen in it inside. I never imagined that. So can we use pollen present in certain different kinds of honey as your geographical indicator to claim that status for India based on the source? And then will you be able to do molecular marker studies on those pollen, if not already done, and collaborate with people here so that we have a good GI for India?
That's actually a very good question, actually. That's actually something that we should actively explore. And we also have a project with Amrita that we are exploring, where we are trying to identify honey. As of today, so I don't know if a lot of people know that we have different types of honey. So when we generally say honey, we are actually referring to something called as multifloral honey, which is actually a collection of nectars that has come from different flowers. It can be wild flowers, it can be known flowers, unknown, whatever, wild jungle flower, whatever. But then you have these honeys which we call unifloral honeys. For example, the most you will not even imagine the plants that we can get those honeys from. Jamun honey, honge, if you've heard of the plant that is there, honge honey, which is very sweet, very beautiful. Eucalyptus honey, you would think it is bitter, but it is definitely not bitter. It's very sweet, very beautiful. You have ajwain, you have mustard, you name it. I can source nearly 12 to 15 different types of honey across the year. So each season gives me different types of honey. And so I'm coming also, how do we identify the honey is mainly through the pollen. So ideally what we do is a very rudimentary thing that the beekeepers or we do as of today is that we taste it, and based on our knowledge that we say, but it's not scientifically valid. So how do you do it scientifically valid? So one would be the pollen studies. So as of now, very rudimentary, I will take a microscope and I will check in that. If I see this pollen, above 30% is there, then I classify it as, let's say, jamun honey. But then that's again very rudimentary. If we had done it in 1970s or 1980s, it might have even made sense. But today, with all the genotypics of the world and everything, that is a very low-key way of doing it. But if we can extract the pollen out, so the pollen are basically repositories of genomes itself of the plant. So you take it out, you match that with the plant that is there, and let's say this particular plant has come from this particular area. So they will have some markers of that specific area. If you can match that, then what happens, you can GI tag the honey itself, saying that this is from this specific place. For example, the jamun honey that we get, most of the thing comes from a place called Jambuti. It's near Karnataka itself. So if you're able to track and trace that and say that it is from this place, and then we can correlate it, that becomes a GI tagged honey. And this can happen to innumerable number of crops, innumerable number of honey, and then we can actually stand our footing in the world itself for honey then, as of now, which we don't have.
So thank you so much. I think, I hope many of you have gathered the gaps that exist in this industry: crops, agriculture crops, horticulture crops, and to beverages, soft or hard. Okay, and then hopefully you will identify, please interact with them. We can provide you all the details and see if there is an opportunity for any of you to become an entrepreneur through IBIOM, through the department. And hopefully when you do have an idea, come with a lot of money from your uncles and aunties. Otherwise, or we can also try to approach the government of Karnataka and all that, as long as the project is good. And some of these people have got very good grants in the past if they have experience in that. So with that, I would like to open it for a few questions before we end. Shekhar is on my shoulders here. So I know we started very late. I'm sorry, we're not to blame here. Shesha, I know you had a question. Anyone else? Maybe 3 questions and then we stop this. Thank you.
Several. Because it's an amazing group where we have, I think you'll all agree with me, that this group of entrepreneurs are, I think, will tell a gamut of the huge kind of thing, opportunity that exists out there. I have a question आपसे पूछना था. आपने बताया था वो कुछ क्वालिटी होना है आपका ग्रेप्स में जो वाइन अच्छा बने. क्या क्वालिटी है वो हम ब्रीडर्स बन नहीं सकते हैं आप?
इंडिया में बनने डेफिनेटली हमारे इंडिया का ब्यूटी ये है कि ईच एंड एवरी डिस्ट्रिक्ट डिफरेंट सॉइल, डिफरेंट वाटर, डिफरेंट क्लाइमेट. हमारे इंडिया में हर एक ग्रेप्स ग्रो हो सकता है, पर हमें जो फार्मर को जो नॉलेज देना चाहिए, जैसे कि आपने हर यूनिवर्सिटी रावे प्रोग्राम सभी करते हैं, पर रावे के लिए ही होता है और रावे के लिए नहीं होना है. उसको फार्मर को यूटिलाइजेशन मिलना है, उसका फार्मर को बेनिफिट मिलना चाहिए. जैसे कि ऑलरेडी क्रियाजन का एक सबसे बेस्ट जो प्रोग्राम है कि सॉइल टेस्ट जो है विदाउट मीन्स फार्मर ने अगर सॉइल भेज दिया तो विदाउट मनी वो आपको एनालिसिस करके देते हैं. अभी मैं महाराष्ट्र से हूँ और लैब जो है बैंगलोर में है, पर महाराष्ट्र से अगर सॉइल कुरियर करता हूँ तो यहाँ से एनालिसिस आपको मिलेगा. जैसे ही एनालिसिस मिलता है तो वो सॉइल जो है कौन से ग्रेप्स के लिए सुटेबल है, ये फार्मर को फर्स्ट पता होना चाहिए. तो यहाँ पे ही हम मिस करते हैं. और जनरली जो ग्रेप्स फार्मिंग जो है इंडिया में ज्यादातर ग्रो न मीन्स अनसक्सेस होने का रीजन यही है कि फार्मर को पता ही नहीं होता है कि वो सॉइल में मुझे ग्रो क्या करना है.
Exactly. So, information पता है तो बताने में क्या दिक्कत है? तो
वही तो इंडिया में सबसे ज्यादा तो कम्युनिकेशन गैप ही सबसे बड़ा है. नहीं वही अभी सी सर, एक्चुअली वाइन इंडस्ट्री का और एक ड्रॉबैक्स आपको बोलता हूँ, एक्साइज डिपार्टमेंट. ऑलरेडी सर और मैं तो बहुत सारा फेस कर चुके हैं उसको, क्योंकि इंडिया में जो है हर जगह पे एक बैक रोड है, फिक्स है, उसमें कुछ इश्यू नहीं है, पर फ्रंट रोड से जाना है तो उसके लिए टाइम ज्यादा चाहिए. और इंडिया में हर एक पर्सन अभी सर्वाइव के लिए जीता है. अगर आप फ्रांस का अगर साइंटिस्ट का बात करोगे और इंडिया का साइंटिस्ट का बात करोगे तो ये दो में डिफरेंस ये है, हम सर्वाइव के लिए जीते हैं. हम रिसर्च करते हैं कि हमें सर्वाइव कैसे होना है, और वो लोग रिसर्च करते हैं कि मींस पैशन. ये दोनों डिफरेंस है सर, और ये जब तक ये कम नहीं होगा तब तक प्रॉब्लम ही है इंडिया में.
Okay, so, yes, so this is a great discussion topic in Chairman's Club. Okay, any one question from the budding entrepreneurs, please, at least 2. Thank you.
Actually, one answer. We had one project for honey in Northeast. It was 15 crore rupees project. Different honeys from which plant the honeybee is taking. So this project is my friend from Coimbatore, Pollachi, was the faculty, one of the faculties. So they gave money, and then how will they find all these are wild honeys? So they gave the money, but all the tribal people they distributed. You know what they will do with the money? They will drink, sleep, and come and list all the plants which are there. Okay. So finally, when they were left with 15 lakh rupees, the people came to us. So what we did was we took the honey, add some water, spin it down. So we have the pollen. And we extract DNA from the pollen and we do typing with the constant markers, chloroplast. There are a few markers are there. And then we could say where and all the trees, all the things, some of them unclassified trees, we could find it in a very short time, and we have 3 publications.
Very good. Thank
you.
Thank you. Yes. Yeah.
More than which plant is actually giving the pollen source. What is important for your export and keeping quality is the contamination of the jaggery.
Jaggery. Okay.
Not jaggery also. So ideally, honey. So jaggery is a very old technology as such to adulterate honey with. So the technologies have gone way ahead. So you have one which actually comes from sugarcane extract, cane extract, molasses, and this thing. But even that is old technology now. So now the latest one from China is called rice syrup. So they extract it from rice, and it's so brilliant. If you import it, it comes with a compendium or this thing ledger, and then in that they will tell you which all tests do you want to pass. So FSSAI has a list of tests. They will say you want to pass this test, you adulterate it by 10%. You want to pass this test, 50%. You don't want to pass, okay, put 90%. You are through. That's all. So the only way to even identify that it's adulterated is through NMR, and which is a very expensive way to do it. And it's that good today's adulteration of honey is.
Okay, so a few questions from the back, please, just for the sake of it. No? Yes? One? Okay, please. Can you come here? Identify yourself and then ask a question.
Actually, it is.
You are. What's your name?
Myself, Jagdish Singh Arya. I'm a breeder in Indo-American hybrid seeds.
Okay. Yeah.
So earlier we were discussing about the BT cotton. BT cotton and BT brinjal. Then I was thinking, what is the need of breeding BT brinjal nowadays?
Okay.
In today's scenario, do you think that you can harvest from a hectare hundreds of quintal yield of brinjal easily, and instead of creating it BT, instead of transferring BT gene into our food chain, it's better to grow it into a net house.
Okay.
And nowadays you can get subsidy of 50 to 90% on net houses from it may be vary from state to state.
Okay, so we got the question.
Yeah.
So I think this panel discussion was more relevant to beverages, not Baigan Bartha. So we'll have that, but it's a very good point. I would like to discuss with you because lack of time. We'll come back to the discussion. Please have a seat.
We can discuss it.
Sure, definitely. Okay, anyone else? Okay, then I think we will stop this discussion. Please give a. Okay.
A small thing. So a lot of the discussions that happen here in beverages are mainly for the alcoholic beverages, and except for this. But as Gajanan rightly said, excise is a very big problem. So any entrepreneurs who are thinking of it, like you cannot even imagine how crazy excise can get. So the alternate to that exists, which a lot of people are not looking at, is the non-alcoholic variants of these. The same variants of juices now there. So this is basically a juice. So you can actually ferment it without alcohol and create non-alcoholic variant of the same thing, and that is viable everywhere. And it's a big thing that's happening across the world. It is coming in slowly into India, but it's not there. But if you can capture it, if you can just take this papaya juice, ferment it, and without the alcohol present. So you have variations. So the most famous is kombuchas, if you've heard of. So they basically fermented tea without alcohol. So even excise has this thing, because most of our foods that we use are all fermented, like curds, your dosa, idli batter, dough. They all have a little bit of alcohol. So there is that leeway in excise that comes in, and these beverages will fall in there. And once you do that, you can enter anywhere and play everywhere.
Very good.
So
Excise ingredient and alcohol is there in curd and all that. They will put that on.
So don't do that.
We cannot. It's become a big problem.
Anyway, those of you.
About 3% alcohol excess is there.
So if you even cough syrups, right? Cough syrups. Yeah, so anyway, so we'll leave it to later in the evening. But those of you who are coming to Chairman's Club for dinner, as being advertised by the organizers here, Kashif has been kind enough to bring honey brewed wine or mead, beautiful color, just almost like a shirt. Okay, natural color from flowers. Please come and taste it, and you may want to popularize that market as well. So then my only concern is,
Ask them whether they will allow something else to come into that alcoholic.
I did mention that, maybe under the table. We'll go like this. Anyway, so
Under the table.
anyway, my problem with honey is that, in Western they call their loved ones honey. And if I want to do it in Kannada, can I call my wife Jane Tupa? Jane, I know, but I cannot call my wife, hey, Jane Tupa, you're so good. Jane. Okay, thank you so much. Thank you. I took a little bit extra time, so you all have a great evening. Thank you so much. Yeah. Thank you, guys. Thank you so much.
And all the non-beverages kind of discussion, cannot bring the beverage without chairman.
Yeah. Can we have one photograph taken with these wonderful people? Please come forward.
So I'm sure after this exhilarating talk about beverages, you all are craving for some hot beverages. So we'll break out for tea, but in the meantime, I would request, because IBIOM stands for startups, so after this tea break, we'll have the startups pitch. So any startup who is not a part of the panel discussion or who has not featured here today, please reach out to me so that you will get 5 minutes time to talk about your idea, your startup, right here on this platform. And so everyone, let's break out for tea, coffee, and meet here in another 15 minutes. Is that all right? Thank you so much. Thank startups, founders, and that is why in every meeting we invite some founders to stand with us. I think it's all again gone. Hello, is it audible? IBIOM platform truly stands for its startups, and that is why we always keep a small slot for startup pitches. So today we have Sanjukta from Pantera Technologies, and she is going to showcase about her product for 5 minutes, product and services. So Sanjukta, if you please come and join us. Thank you.
Like I have done my PhD in fermentation. It's under IBSD, that is the DBT funded institute in Sikkim. And in that I have done about the bioactive peptides of the fermented products. And here I am in Pantera so that we can get a product out of fermentation or out of using the microbes, beneficial microbes, to enhance the soil health. Okay, so let me introduce my our company. So it is Pantera Agri-Science. Yeah, sure. Agri-Science India Private Limited. So our logo is this one. It is similar to the infinity symbol, and it symbolizes a connection between soil, water, and vegetations. Then it is the fusion of Panta, that is the perpetuity, and Terra, that is a land, and NEM embodies our committing to nurturing of the Mother Earth. Then this is our vision, that is to cultivate a world where agriculture and environmental stability harmonize seamlessly, ensuring a thriving planet for generations to come. Because nowadays we all are facing problems like our soil is not fertile, then people are using fertilizers, chemicals, and all these things, which is coming indirectly or directly to our ecosystems. So these are the product categories we are manufacturing. These are the micronutrients, then biofertilizers, biostimulants, and adjuvants. So micronutrients, we are going to use all these things. Then we have some products which are going to be launched in market very soon. So these are Estrio, Mefir, BF4L, then BF8L. That's it. I don't want to take much of your time. Thank you very much.
Oh, that's good.
Yeah. So thank you, Sanjukta, for that talk. So now we will be having our next talk, but before that, a small quiz for our audience while the laptop is being set up. So over to you, Raja sir.
Folks, this is not small quiz, it's a big quiz. Go to your group. There is a quiz posted. It's there is no negative marks. You can start answering while other people are talking also, because all are easy questions. We already told. The first 3 people will get a prize. Though all of you will get certificates, 3 people will get the prize. So you all got the quiz, no? The link for the quiz. It's a Google quiz. So old monks can also use the quiz. They can check their knowledge. Even legal people can also legally test their genomics knowledge. All questions were leaked, and I'm sure that you can get that. Minimum pass score is 15 marks out of 52. Even if you randomly click something, I think you will get 15 marks. So over to Purushottam to open his PPT and let the games begin. Are you in the group? So you are answering. I am also going to answer. You can also answer.
That is present as you know. You are right. That is okay. It is important that I am audible to you, whether it is with mic or without mic. So we are going to talk about eco-intelligent farming, advanced residue-free pest and nutrition management. In this today, we are going to talk only about the pest management. I want everybody's attention. See, you must have experienced the pest management with the spraying of the chemicals, and unfortunately, as you are aware that you actually spray the chemicals onto the edible parts of the plants, crops, which you actually do not want. But is there anything that that can change this scenario? Okay, we have been working on to this last 8 years onto this one. Okay, we have been developing the semiochemicals. These semiochemicals are, are going to do the job that we are expecting them to do. That means they will help us to control the.
You have to show this side, not to the screen.
Okay. They are going to see, these are the semiochemicals. They are going to do the job of a pest control or pest management without using those toxic chemicals or without you spraying those toxic chemicals. Okay. So semiochemicals, what are the semiochemicals? Semiochemicals are, in a simple language, they are the language between the species or in the ecosystem. That is what we are working on. We are trying to exploit how the two insects or the insects and the plant species, they communicate to each other. You will be surprised that this communication is so powerful that the female, if releases some kind of a pheromone, the male can smell it 4.5 kilometers away also. And then the mating happens. Now what is our purpose? We want to control the population of the pest using this one. So we are going to exploit this phenomena, the communication between the insects. So this is the history of the semiochemicals. I am not going to go into the details of this one, but I just want to highlight that this has been being studied since 1870. Recently, this you will be able to see that recently this has been in 1957 itself, the electroantenography. This is a very unique technique that today also being used for the discovery of the semiochemicals. I will try to explain you how the semiochemicals are discovered and utilized. That's all 2 points I'm going to cover. I'm not taking too much of your time. So this is a classification specifically. I just want, when we talk about the semiochemicals, people are mostly aware of only the sex pheromones, the pheromones that are released by the female and sensed by the male. But that is not the case. There are different type of other chemicals which also communicate between the species, either within the species or with other species. So when the chemicals communicate with other species, they are called allelochemicals. And there are chiromones which benefit the receiver, then allomones which benefit the emitter, and cinomones which benefit both. I mean, and this is a classification that I just want to highlight for your at this point, that it is not only the sex pheromone you can utilize. Actually, we have been working on to exclusively onto the chemicals which are not sex pheromones, and I will explain you how we are doing that one in the coming slides. So these are the application of semiochemicals. Specifically, it is for the pest management, and how many type of pest management you can use it for detection and monitoring. If there is a pest, farmer will only come to know when there is a damage. But this is a technique which will tell that before the damage to the farmer that there is a pest presence into the field. And the control and management, you can do it by 3 ways: by mating disruption, attract and kill, and mass trapping. Now here it is an interesting slide. Here you will be able to see how actually, what are the semiochemicals and how actually they are discovered. This slide will explain, see, why particular insect infests the particular species of a plant only. That is the question. So suppose there is an insect which is a tomato leaf miner. Why does the tomato leaf miner infest the tomato only? Why the fall armyworm infests majorly the maize? Why the diamondback moth will infest the cabbage? Okay, there is a communication between the plant and the species, the insect species. So you can see that here what we are studying is actually we are studying the chemicals that are released by the plant, and those chemicals released by the plants are absorbed onto the one adsorbent, and then they are eluted, and then they are analyzed, and we come to know how many chemicals or what are the major chemicals that these plants are emitting, which later on will be studied
This is the identification of host plant volatiles. I will show you in current project that we have been working on to what kind of chemicals we have identified. And then what happens is, this is an electroantenography, as I mentioned into the my last introduction and the history of the semiochemicals. See what is happening here. Here the antenna of the insect is mounted onto the electrodes, and the semiochemicals that we have identified or being released by the plants are released or run through the GC, and the semiochemicals are separated and they are sprayed onto this antenna. At a particular point where the particular semiochemical is detected or affecting the behavior of the insect, that point the current is generated or the signal is generated, and then the scientists come to know that this particular semiochemical is creating an excitement or inciting the insect, and that is how they are identified. Then it is not a one chemical that will elicit the response into the insect, but there may be a few chemicals. So the scientists that, or we are preparing the blend, and that blend is tested into the olfactometer. What is olfactometer? Is actually the formulations are, see, these are the two arms of the table. Formulations are made. One is of the attractant side, one is a neutral side, and the insects are released from that side, and which side they are going. It's a simple mechanism, but here what it shows is whether the semiochemicals or the formulation or the blend that we have prepared, whether it is working as an attractant or a repellent or not. This is actually laboratory test, and then finally it comes to the field trials, evaluation in the field efficacy. That is how the Crop Jeevan Agro Research and Development Private Limited, the company that our startup company is working on to the discovery of semiochemicals or some new formulations. Any question onto this one? Okay, this is how we are doing it. Actually, this is a rearing of the insects, and you can see here some of the moths in our laboratory. And these are the larval stages, where from on the it will go to cocoon stage, and then moth will come out. See, this is very interesting. What happens when you go to the field, and what are the chemicals that are released by the plants are collected, and then they are onto the GC. They are identified and compared with the standards one, and then these semiochemicals are identified as a list of the chemicals. But all of these will not be the active chemicals, so we identify them through the electroantenography. And then we come to know which are the chemicals that may have the in EAG profiling identified the promising volatile organic compounds. Okay, this is what the actual antenna is mounted onto the electrodes. And this is a diagram of the olfactometer, where you have on one is a test and another is a control chamber, and the insects are released from this side. So we are also working on to the different formulation. Mostly the existing formulations are the rubber based septas, but we have developed material which is not affected by the temperature. Usually the rubber septas are affected by the temperature, and also they are difficult to be handled. So our new formulation at least have the double of the efficacy at the same concentration than the rubber septa. Any question? I think I'll end up. These are some of the results. Thanking you.
They are water soluble. They just evaporate.
They just evaporate. They are the dispensers actually to dispense the smell. They are not water soluble. They don't need to be.
They don't need to be. They just.
They are they are dispensers which will release the semiochemical out of them.
what are different insect host combinations you work, no?
Yeah, we have about 25 insects, and we have identified some of them are already known. Known semiochemicals are there. So, but
Which works across different insects and different.
very good question. This is what the uniqueness of the semiochemicals. Semiochemicals do not affect the other insects. Semiochemicals are very target specific. So if you have this, because it is a communication, it is a very delicate communication between the species. So Helicoverpa armigera or tomato leaf miner, Helicoverpa armigera will only call the species, the male species of the same insect, not the male of other species.
But then there are insects which are working, which can attack different crops. So does it work across different crops?
See, there are two ways to identify the semiochemicals. One is based onto the volatiles of the host plant. Okay. Second is based onto the pheromone that is released by the insect. When your question is that when the host plants are different, then our formulation should match that the host from the volatiles from the host different host plant should be there. Then only it will work.
What about the effectiveness? To what extent you are able to protect the crop? 100%?
No, not 100%. There are three methods that we are protecting the crop in this way. First thing is that this is a prophylactic treatment. This is a before the disease comes. One is a monitoring. Before you see the damage, you know that there is a pest. If you see that insect into the trap. Second is a mass trapping. Once the insects are there, you can put an additional traps into the field and mass trap the. What happens is once you trap the male or a female, male and female mating doesn't happen, and the female laying the eggs onto the crop doesn't happen. So we are able to control almost 60 to 70% of the damage before the damage happens.
So, Purush, within you said that they're very precise, right? So
They're very specific.
Very precise, and one pheromone can only make a female attract only one kind of male, which affect one kind of crop. One crop.
See,
which feeds on one crop.
Which feeds on, see, one species of insect usually doesn't affect the single crop. See, for in case of Helicoverpa armigera, you will find that one into the cotton also. You will find that one into the ladyfinger also. And but some of the insects, they are very specific to the host. Like pink bollworm. Pink bollworm is the insect of the cotton. It will find on the cotton. But like FAW, fall armyworm, it is a polyphagous insect. So it will be found onto the multiple.
Can one kind of trap attract pests that causes damage to American bollworm as well as pink bollworm?
No, one trap will not be able to.
Not one, meaning one type of trap.
One type of trap is specifically designed for one insect. American pink ball. And that is advantage. See, what is happening here, we are not affecting the beneficial insect into the ecosystem. It's very innovative. Actually, we need to work a lot, and lot of companies, lot of startups, you people need to work. It will not happen with the one company, or we are not going to do everything, or any other companies those are going to do. So I encourage the youngsters at least to venture into this one, collaborate on to another thing that I was mentioning yesterday morning, that we are trying to, these semiochemicals are very much stereo specific. They are either E isomer or G isomer, E G combinations, all these. And being very stereo specific, synthesis is very challenging. These are not the small molecules, these are the big molecules. And if you people can develop, I was talking to our senior lecturer just now, if we can develop some kind of a trait into the crops or the plants, which will elicit the synthesis of particular semiochemical in that crop, either it is attractant or repellent, Mithur sir. Okay, if we can breed particular plant to produce some kind of a semiochemical which will repel the pest or attract the pest. If it repels the pest, then we are saving the crop. If it attracts, we can use it as a trap for the other insect. We can put that one onto the boundary of the farm, and then the insects get attracted towards that particular crop, and then we save our main crop.
So what you're saying is if a crop can intrinsically find that chemical out, then
Chemical.
you don't need traps.
You don't need.
Very nice. Has anyone gone in that direction by anyone in the world?
No, not yet. I mean, people are trying to do it. People are trying to do it. Certainly. This, you know, these semiochemicals have become very a talk of the day recently in last 5 years. I mean, a lot of people have been working onto it, but still I can tell you there is a lot can be done. Lot can be done. I am very thankful to all of you for an opportunity, and I'm really, you know, happy to answer. So it is 100% approved for organic. You don't need the approval also, because reason is that you are not spraying anything into the environment. See, what I'm doing, I have this outside, there is a stall. You have the tablet, you are putting the tablet here. This is your field. And what you are doing, you are attracting that particular insect into the trap. So the in India also, Central Insecticide Board doesn't stop this one. See, I showed you this kind of a rubber septa. We have to change every 15 days. But this one, that what we have developed, you can change it into 90 days also. It will keep on releasing. See, this depends on the formulation. That is what we are working on to. We have some of the formulation as a gel formulation also, where we are trying to maintain the sustained release. What happens in case of rubber septa? As I said, that it is affected by the temperature. When the temperature is high, the porosity of the rubber increases or it expands. Then the release rate increases. But that's what we are moving on to, the very unique material as a dispenser material, where it will not be affected by the temperature, and you will have the sustained release. Thank you very much. Very intelligent question, both the question. See, as this is not being eaten by the insects, okay, there is a very less chances of having a resistance. And these are the chemicals which elicit the behavioral changes into the insect. Not they do not work inside the insects. They do not get injected into the insect, and they work at a nanogram quantities.
There is no genetic disturbance.
There is no genetic disturbance. As such, what happens when you give the pesticides, it affects either nervous system, respiratory system. But here, what you are trying to do by using the semiochemicals, you are just using their natural phenomena, what they use. You are using the female sex pheromone to attract the male. That is what happening into the nature. And it has been happening for the years. And it will keep on happening.
How do you, just an offbeat question. So we have a lot of monkeys in our fields. So what do you do when they come and disturb your system? Just pull it down.
See, particularly these are the very monkey proof. I have not come out, but
that's not your problem.
No, that is going to be the problem. That is good. See, what we are trying to do is, very good question, but you know what we are trying to do? We are trying to develop in a jail. Very good question. You know, I didn't expect it, but practical. Okay. So what we are trying to develop, we don't want to use a trap. Now we are trying to develop some kind of a gel which can be applied directly to the plant. We are trying to apply it to the plant itself, so that what happens, the insect gets attracted and it sits on the gel, and gel has some insecticide, so insect gets killed. Thank you very much. Thanks a lot.
Thank you, Dr. Purushottam. So So that was really insightful. And as always, let's catch up after this, and because I'm really interested in your product. So everyone, a small gift for Dr. Purushottam, sir, if you can please come this way. Yeah.
Will you sir keep joining us?
Yeah, please.
We'll have another picture.
Right. Okay, so now I would like to pass on the mic to Raja sir for the vote of thanks and prize distribution. Thank you.
Thank you all. All good things have to finish, and good things are getting finished. I'm seeing that everyone is tired and want to hit the bar, right? Saturday evening. Some 30 people are coming, but I'm not seeing 30 people inside. Maybe 30 people are here. Maybe people already reached the bar. Or they used his tablets, put the tablet in the bar, and people have already gone there. Yeah. So thank you, all of you. So firstly, I want to thank few people for making this a success. Dr. Surya, mic is working or no? So Dr. Surya, please stand. Is from Genomics. Suresh, bioinformatician. I think without him, we would not have done this workshop. Almost everything done by Suresh ji. Purnima tried to clean this one with ethanol after the experiment, and now UAS Dean has slapped us 7,500 rupees for revarnishing. Or either Purnima brings varnish and make it all right. I don't know, but we said we'll donate 7,500 to the institution and also another 7,500 for cleaning. So we are going to, so Genotypic is going to give 7,500, and from IBIOM we are going to give 7,500 to, that's a good donation for the institution. So Krishna Prasad, yeah, everyone, Krishna Prasad is there, who is an alumnus from here, MSc, BSc from Agriculture University. So he did all the running around last 2-3 days, doing everything, along with Partha, who's here from Genomics, and Srimati, who was taking care of your registration. And you'll be surprised, the whole thing was done with only 2 weeks advance notice. I think most of you know only 2 weeks before, right? Only 2 weeks. It was surprising for us because of other things. It got postponed. And then thank you all of you for coming. And then there are volunteers from UAS, of course, Dr. Sesha, who was more than willing to help. And he also did running around to get the halls, this, that ready and all. And then there was Ganesh, Virupakshi and Jivita from Shesha's lab and UAS who did it, and Skandan from IBIOM, who is like a one-man bollworm kind of an army, or what they call the army worm, no, or something they call. So he chewed through all the work. Rover. He chewed through all the work, and without his pheromone, he was always there. So thank you, Skandan, for taking the real workload. And then, of course, Shekhar Shuman, who was supposedly come yesterday, and his people. And I hope you all smiled when they were taking the picture, and hope you are not sitting next to the wrong guy or the girl, because it's going throughout the world. Okay. And then Miturji. Thank you. Yeah. Yes, and his team who came on the last minute. You're also hitting the bar, I suppose. And his team. And then Miturji. IBIOM folks, all the trustees, everything. And there are so many people I have to thank, particularly the sponsors, Jenny Lab. Where is Aldon is here. He also sent one team for you to learn about extraction. You all thought extraction is just lysing and taking it. I think you had a little workshop yesterday, how it's extraction professionally doing is different from that. And we also had a speaker, a scientist from there speaking. Thank you, Aldon, for sending it. And Crop G1, he spoke about how he is going to use the chemicals for that. And then Oxon, he is also the sponsored. I think the bag was here. They made one. I think I asked that question. It was out of syllabus question because he didn't speak. They made one concoction of microbes, which he gives in a small little packet. It will not only fix nitrogen, it will also help plants bypass drought. I don't know what bacteria is there. I told him I can find it out very easily, and anybody here knows how to find it out. He cannot keep the secret. If they're alive or dead, we'll find it, right? So that's the confidence at which I think you guys have to go is alive or dead, you will find it. And I'll request Kandan to look for who's the first prize winner, first three on the thing. So, and then director of PG studies, postgraduate studies, who came and spoke with us. Sincere thanks. It is their call. He would have never expected someone would be doing sequencing on this table. You guys did it. So thank you, all of you. And now it is the certificate giving time. So who is going to give? See, we have a professor, I think people didn't tell. Dr. Pius Thomas is a professor of horticulture in IIHR. I don't know exactly which department. I knew him a long time back. Now he has his own company. He spoke about the papaya thing. So he might be missing the academics. So we are going to give him the pleasure of distributing the certificates to you. Cheta, hey, who has the certificates? Please read out the names. Anyone wants to read out the names and so he can give it?
Yeah. Okay, there are so many. Oh. So, all of you excited to get the certificates? Okay. So, the first certificate goes to Soumya MS. Can you please come over?
I'll get the prize winner.
Yeah. Next person, Saif. Saif is here? I don't see Saif. Okay. Brijesh Kumar Singh. Not here. Prajwal. Vedashri. Channa Basawa. Ashwini. Yeah. Ashwini M. Jadesha. You're Ashwini M? M. No, only M. Dr. Yamunura. Dr. Vinay B. Raghavendra. Not here. Alden. Shiva Kumar YM. Not there. Manjunatha M.
Vinay is there. Is it Vinay at the back?
Kayal Vili Ulganathan. Okay. One second. You just take this one, Kyle. Dr. Vinay B. Raghavendra. Prashanta V. Sanjukta. The next one, somebody else has to come because the name is Thomas Pius. Somebody else has to come to give him. I would request Mithur sir. Please.
It's always a pleasure to be here.
Donia. Donia. Not there. Rachna Pawar. Not there. Shirisha KM. Pramodini Harisha. I guess she's not there. Gopi A. Kashif. Mr. Noor A. Mujassim. Ganesh KR.
I wanted to show something. See, this is the insect. We have the rhinoceros beetle attractant here. So from somewhere this insect has come. This is, an actual practical example of how the attractant works. Big hand.
Suprita Raj. Meenakshi Saravanan. Ashwini MN. Sachin G Rathod. Sachin G Rathod. Ashwini Gopal Lamani. Ashwini Gopal Lamani. Supriya Ramacha.
Sure. Okay. Ashwini is desperate to ask one question. Please ask.
Thank you so much for the opportunity. So I'm basically from plant breeding background.
Okay.
So plant breeding mainly focuses on product development, but another aspect of plant breeding is also the conservation.
Yes.
So most of the startups, companies that are working in India or in other foreign countries, they are product oriented. In India, if anybody wants to do a startup about the conservation through the application of a genomics, is there any funding agencies which supports them for these? Because it's very difficult to get the funding for such kind of work. Most of the funding agencies, they focus on the product oriented. First question they ask is what is the economic importance of that particular thing. But I personally feel we also have to focus on this conservation aspects. So is there any sector we can approach funding agencies?
I just love the question. I think this is really hits the root of the problem. We don't seem to be, we are so capitalistic oriented. Sometimes forget that we have to sustain our forests, our conservation, our land and valleys and rivers and all that. So I mean, finally, we need to go to the Department of Conservation, Department of Forestry, All Health. This is about all One Health. Many people don't realize that. So I don't know if there is any agency which can fund, but we will keep the question in mind. Please be in touch with us. You're in CMAP, right?
Yes.
CMAP and Dr. Dinesh Nage Gowda, right? And also Yogendra. So I'm in touch with them. So maybe through them, you can get our contact. In case we come across something, funding agency, we will let you know.
Thank you.
Thank you so much. Yeah, thank you.
Supriya Ramacha. Afra Fatima. Afra Fatima. Nagana Gowda Patil.
So no other advocate will take you for granted.
Definitely. Thank you so much.
Muthu God Revantagan, Dr. S.R. Sivakumar, Muthu God. He didn't come. You want to receive? Okay.
Receive on his behalf.
Dr. S.R. Sivakumar, Navya GT, Megharaj KC, Bhumika PK, Shashank S, Fauzia Taranum, Fauzia Taranum, Cornelius, K. Prasad Babu, Dr. S. Manjula, Prasad Babu, yes. Dr. S. Manjula, Edward Roy S, Mr. Brahmesh Reddy BR, Brahmesh on Brahma, okay. Maunika Kancharana, Dr. Virupakshi, Dr. Virupakshi, Jivita, Jivita, Munia Lakshmi, Sukant BS, yeah. Sukant BS. Yeah. So with this, we come to an end of our session. I'll pass on the mic to Raja sir.
Hey guys, now it is time for the prizes. Firstly, the teachers won because it was a test for the teachers, not for you. So most of them got closer to, there were 50 marks. And because some of you might say it is out of syllabus question, boss, what will you do? Another 4 questions were added, bonus questions were added. Okay. So there were 54 marks, though counted for this thing. The lowermost mark is only 26. So you guys, teachers, I think did a good job. And then we also had a QC, our Partha from QTL was taking help of the 3 teachers and he answered. But Partha got only 2nd rank. So 2 other people got 1st rank with 44 marks. Any guesses? One is our own Prasad Babu. Prasad Babu. Who will distribute the prize for him? So he gets, because
No prize money, sir.
Prize money will come. Honey will be given. No, we are doing 2. That's because they all learned what the value of pyramids. So it's pyramidal. So 44 marks. And Saumya also got 44 marks. So you also get the double. Congratulations, Babu, Prasad Babu. Avaru Saumyaku 2 kodutಕೊಳ್ಳಿ because they got the same marks. 44. Okay. The third one is who scored 43. And then the lots of people scored 42, 39, 41 and all. Prashanta. I hope you guys didn't copy from each other. No, don't give. They were sitting right next to each other. No, just kidding. Congratulations, Prashanta. So with this, everything is over and we hit the bar. So basically, you all have to come in the front of the department, the north block, that side. And we'll have different cars and we take. It's only 6 o'clock. When does the bar open? Or are we going to open the bar? 7 o'clock, But 7, see, we should start now itself. By the time it will go to 7. And our professor, IHR professor, Pius Thomas, is offering mocktails just as a warming up for everybody. Build up. I'm building up. He's warming up.
I don't know.
I have 2 announcements.
Somebody staying in the guest house. Who is staying in the guest house? Okay. Are you going to leave immediately or